Hey, good morning from FathomWorks. This is Brendan Applegate, and I want to thank you for joining us for the culmination of the 15th Annual Coastal Trident Port and Maritime Security Program. I am the Principal Investigator from NSWC Port Hueneme Division and the ANTX Advanced Naval Technology Exercise Program, which has leveraged the Coastal Trident program since 2017. I'm going to talk a little bit more about that later. As I introduce the program and talk about Coastal Trident and how ANTX fits into that and meets the technical needs of the Navy. But before we get started, I'd like to introduce you to our commanding officer at the Port Hueneme Division of the Naval Surface Warfare Center, Captain Andrew Hoffman. He's going to give us some opening remarks that will focus our attention and set us up for the day. Sir, are you with us? Thank you for joining us this morning.
Brandon, I'm here. Good morning. Can you hear me okay? Can you see me okay?
We got you, sir. Thank you.
Awesome. Thanks so much. So do you want me to go ahead and kick it off, or you ready for me to start talking?
Yes, sir. Go ahead.
All right, let's light this candle. Hey, good morning, everybody. Thanks for having me. Thanks for joining us. Love that we're going a little bit hybrid. We're doing a little bit of online and a little bit in person the next couple of days. So this is really cool opportunity to kind of flex our digital transformation skills. You know, for me, it's been an honor for members of this command to engage with you throughout the month. I'm truly excited of sharing the results of many of the exercises held and how they could potentially impact the Navy and our maritime government partners. So a little bit about us, if you don't already know. The Naval Surface Warfare Center Port Hueneme Division is the Navy's center of excellence for in-service engineering, test and evaluation, integrated logistics support, and for warfare, combat, and weapon systems since its inception in 1963. We have provided highly skilled personnel and state-of-the-art facilities to lead the development and support of the Navy surface warfare systems throughout their life cycle. Port Hueneme is one of 10 warfare centers nationwide that fall under the umbrella of NAVC or Naval Sea Systems Command, if you're not familiar with the acronym. While the NAVC warfare centers provide support to our warfighters and transition capabilities to the fleet, we know we can't do it alone. We must partner with the great minds and innovators that exist in academia, industry, and other government organizations. What you will see today and tomorrow is an example of this collaborative approach. In fact, some of these technologies originate from small companies and academic labs, as well as some of our sister warfare centers. Port Hueneme Division is as the fleet's lead in-service engineer agent, is focused on advancing its workforce to meet the Navy's future demands for this mission. It probably comes as no surprise this annual event has looked at new technologies which advance that agenda, such as augmented and virtual reality, digital engineering, remote technical assistance, and unmanned systems. It's also why we participate in the ANTX-Coastal Trident program this year, along with several goals to build technology interchanges with new partners and expand previous year's partnerships. And that's why this program is centered on rapid and affordable advancement of our new capabilities to the fleet. ANTX and Coastal Trident are a key bridge to between those who need capabilities and those who might develop them. This event is an opportunity for the public and private sector to work together and ensure our Navy and government partners have the tools they need to effectively address threats to our national security. Some of the exercises held from April through September up and down the California coast reflect the goal of addressing potential threats. For example, one scenario involved the simulated discovery of a mock radiological weapon found on an oil drilling rig off the coast of Huntington Beach. The event looped in personnel from the U.S. Marine Corps, the Coast Guard, and the Los Angeles Sheriff's Department. The agencies responded with tactical hazmat, bomb squad, and dive teams aboard small boats. Our command team members supported several field experiments, including mock salvage of sunken ships here at Naval Base Ventura County that incorporated 3D modeling using underwater remotely operated vehicles and dive helmets with 360-degree cameras. Pretty cool. We examined how airborne drones can assist with surveillance and damage assessment, but also how they can pose a direct threat to our nation's security when operated by our adversaries. There's a sense of urgency when determining the readiness of these technologies to be fielded. We need to move from ideas to placement and execution faster. As leaders, we need to tear down barriers and solve pressing problems and challenges for both in-house innovators and our technology partners. But it's also incumbent on all of us to steward our resources effectively, work together to deliver the systems our Navy and government partners need to react quickly and forcefully every time there's a threat. We need to boldly take risks despite the possibility of failure. Every year we hold this event, not all of the technologies being tested are successful, but that's okay. We are willing to take the risk, try new things, and learn quickly from our mistakes. If you're joining us in person tomorrow, you will see many of these projects displayed in an effort not only to demonstrate what they accomplished, but more importantly, to share knowledge and encourage collaboration on new concepts and ideas. I would like to thank our partners, the Ventura Economic Development Collaborative and Matter Labs, for facilitating this Coastal Trident components of the program. I would also like to thank our gracious hosts at the Port of Hueneme for the use of their space. And finally, thanks to all of you who have made it your business to ensure safety and security of our nation and those who serve it. Thank you for partnering with us in this endeavor, and thank you for your support. Now I'll turn it back over to Brendan, who will go over today's agenda. Thanks very much.
In San Diego, on test ranges, flying unmanned aircraft. We've been offshore on vessels. We've been offshore on vessels off the coast of Los Angeles and aboard offshore oil platforms there. We've been also on vessels off the coast of Ventura County and here in the Port Hueneme and at Naval Base Ventura County. It's a very distributed environment, and that's where we're doing the learning that's associated with the Advanced Naval Technology Exercise and the Coastal Trident program. Learning about all the capabilities that are necessary in the port and maritime domains, where they work, where they don't work. So like I said, we've done the learning. Now it's time to enable the engagement. What are we going to do with all that knowledge that we've acquired? How are we going to find out whether the capabilities that we're developing and the capabilities that they're demonstrating are going to meet the needs of the operational stakeholders in the Department of Defense, the Navy, which obviously is part of that larger department, maritime law enforcement, maritime emergency response organizations, critical infrastructure stakeholders such as energy infrastructure in the offshore platforms, port infrastructure in the commercial and government ports. All of those capabilities have a role in this domain, and Coastal Trident and the ANTX program are geared towards validating those capabilities. So now that we've done the learning, it's time for the engagement. We want to tell the story. We want to make the connections between the technology and the users. And we want to plan the next steps. And that's what this open house is designed to be, is the opportunity for that engagement to occur. So you can see on this slide that the goal for day one is to summarize the ANTX program, the Coastal Trident program, how they fit together to achieve this engagement. We're going to get some briefs by the Navy Warfare Centers and strategic partner organizations and other departments on what their technical needs are. So that will give you some context of how ANTX and Coastal Trident fit together to meet those technical needs. And then we're gonna, while we're at it, we're gonna give you some select presentations by ANTX-Coastal Trident project groups that show how the programs within, the projects within ANTX and Coastal Trident work to meet those technical needs. We're gonna learn about the role of ANTX in accelerating knowledge, making sure those capabilities fit the operational demand, how we transition those technologies into the hands of the users, and then make sure that we set up for productive discussions during tomorrow's in-person session. So this time around, I mentioned that we're having virtual. Obviously, we're here virtually. We're going to have in-person sessions going tomorrow. A little bit different this time. This is the first time we've done this format. So appreciate your flexibility, your patience with us as we navigate this challenging environment. Last year, as you know, we did this event entirely virtually in the midst of the COVID-19 constraints, with large gatherings, with travel, and with in-person events. So this year we've got a little bit more freedom, as many of you know, many of your offices are returning to work in some capacity or another. So we're able to do an in-person event, but the demands of our command to mitigate the risks of COVID-19 were that we minimize the excuses for people to gather in large groups, to sit in front of large presentations and really get together. So you'll see tomorrow that in the FathomWorks space, we have a large, wide open, well-ventilated space to mitigate the risks associated with COVID-19. We're going to have some other mitigating factors in place. Everybody here in the room is going to be wearing a mask except for the speakers, so I've got mine. You'll see that in effect tomorrow. But again, today is just to get those items out of the way, to get the presentations and set up the context for the in-person discussions that are going to happen tomorrow, and get those in place so that we can engage in a meaningful way. So today, as far as the agenda goes, we're here in welcome and open remarks and the program overview. We've covered that a little bit. We're going to be ahead of schedule, leaving some room for the presentations by our speakers to flex a little bit. Another thing I want to mention is the presentations today are going to go a little bit in a one-way direction. For the virtual presenters, they may or may not be able to see questions placed in chat. For the folks here, it may be a little bit difficult to address questions. If we can get to them, we will. If we can't, rest assured that we're recording those questions, and we will follow up with the speakers and provide those questions, make sure they get a chance to answer them and get back in touch with you. So again, thank you for your patience. Thank you for your flexibility. Another note, there may be some background noise in this area. We are in FathomWorks facility. We are in an operational port, so there are a lot of things going on around us. We've done our best to set up a productive environment that is going to allow us to have these discussions and provide you the briefings and the presentations that are going to enable the discussions tomorrow. But it's going to be a little bit adventurous. This again is the first time we've been doing this event in this format. So we're learning every year how to do it a little bit better. If you've got feedback for us, feel free to reach out to me or to Alan Yeager and provide us with that feedback. So with that, we're going to go ahead and get started with the program. So the first part of the program is going to set us up for discussions taking place tomorrow. We're going to hear from several operational stakeholders representing the users of technology in the port and maritime domains. Some of those users are Navy. Some of them are interagency partners from the Department of Defense and the federal government. Some of those are going to be representing state and local government, maritime law enforcement, emergency response organizations that use these capabilities in the port and maritime domains. And the point of this is to align what we are all developing as far as technology goes with what the need is out in the port and maritime domain, by the government, by any of the other organizations that are operating out there, and they need to do so safely and effectively. So there's a need, there's solutions. This is the intent of this part of the program is to align those needs with the solutions that you all are developing. Tomorrow during the in-person session, we'll have the opportunity to have roundtable discussions where some of those stakeholders and subject matter experts from the warfare centers and from the operational commands will be available in a roundtable format for you. So today you're going to hear about what their needs are. If you're developing solutions that are relevant to those needs, you'll have an opportunity in the afternoon portion of the program to sit down with those and talk about them. Those might turn into opportunities to pursue programs next year, later in the year, whether it's part of ANTX-Coastal Trident or another technology initiative. That's the goal of this part of the program. So for the next couple of hours, we're going to be doing that. Again, like I said, this is the agenda for today. This is kind of the intent as we set out on this adventure, but maintain a little bit of flexibility, a little bit of a sense of humor, and I think we'll all be well served by it. So this portion of the agenda is intended to go to 10 o'clock. May go a little bit longer. We're a little bit early in the program, so we've got a little bit of flex time. We may have to slide into the break if these presentations go a little bit long. I'm going to do my best to keep the speakers for this portion of the program to 15 minutes, but I want to make sure that they're communicating the information that you need. So some of them might go a little long, some of them might go a little short. We may bleed into the break, and if that ends up being the case, please just take the breaks as you need them. Like I said, please maintain a little bit of flexibility, a little bit of sense of humor as we're navigating this environment. It's a little challenging for the first time. So after these operational stakeholders presentations, I'm going to come back and talk to you a little bit about the ANTX-Coastal Trident program, what it is, how ANTX fits into Coastal Trident, what that means, what we're trying to do here for the last 5 months. And then we're going to have project briefings by select ANTX projects. So you've heard what the need is. You're going to hear a little bit about how Coastal Trident is put together to fit that need, and then how projects within Coastal Trident and ANTX further meet those needs and really drill down into addressing those on a case-by-case basis. Then we're going to come back and close up the session and get set up for the in-person day. We're going to have a bunch of exhibitors in here setting up for tomorrow. I'm going to give you an overview of what the agenda for that is. And then hopefully we'll see you all for our in-person event tomorrow. So we're going to start off with the operational stakeholder presentations with Mr. Kail Macias. He's the technical director from the Naval Facilities Engineering and Expeditionary Warfare Center. Sir, if you'd like to join us.
Hey, good morning, everyone. Super excited and honored to be here today. Coastal Trident, we participated in quite a few over the last few years, and it's been such a great venue for us for many reasons that I'll talk about as we go through. But before I get started, I just really want to acknowledge and express my gratitude for those who made this possible. First, Naval NAVFAC Port Hueneme Division for being the lead within the Naval Research and Development Establishment for Coastal Trident. Also would like to thank the Port of Hueneme, not only for being such a gracious collaborative partner and us leveraging their space, but also working together on very similar issues as we go through events like this. I'd also like to thank Matter Labs, who really does a lot of the up and down lifting and the behind the scenes for events like this. And then lastly, would like to thank the Economic Development Collaborative. You'll see on one of my slides, we reference them, but really they're key for that engagement with industry and academia, and really make this this community of looking at technology and how to quickly test it and be able to transition it to the warfighter is really key for us. So anyways, I'm sure there's other folks, but my gratitude to them for making this possible. Next slide. So here's a quick overview of our command and what we do. Oh, thank you. So I'm just going to start from the bottom, and it's really the context of bases to places. So, and then as we go up to, you'll see the main three domains we work in, from shore, oceans, and expeditionary. And as I get past this slide, I'll talk about some very specific technology areas that we need help with and would love to work with many of you. But just real quickly, bases to places, that can be from an enduring, whether it's continental US or overseas, to cooperative security locations, contingency locations, all the way to advanced naval bases and expeditionary advanced base operations. So we are the command within the Navy that supports the Naval Expeditionary Combat Command. So when we get further down to that pointy end, we're the ones who provide the equipment, the tools, and technology to enable our forces to operate in that realm as far forward as possible, from a really small unit to battalion size expeditionary camps. So that's an example of going from bases to places. Now I'll pull it back here. From the basis standpoint, we're the command that provides the new technology and in-service engineering for a lot of different functions. As you look at those icons, like for shore domain, one thing that pops up, that first one, CSTB, that's Control Systems Testbed. For NAVFAC, we are the technical authority for all shore industrial control systems. Cyber right now is a huge deal. You do not have to look too far in the news at the Columbia pipeline and incidents that are happening all over. It's an easy target that you look at to get in and be able to create havoc and cause problems. So anyways, I'll talk more about this, but that's just one example in the shore. The other one I'll talk about too a little bit is energy and water. Huge deal for us from a resiliency standpoint. When you start to look at environmental factors and climate change or climate crisis, I'll talk about that, what we're doing and where we need some help on some of those technologies. Real quickly, the oceans domain, the piece I'll talk about there is the waterfront stuff that we do. And really key when you look at the importance of critical facilities such as piers, dry docks, wharfs, magnetic silencing facilities. It becomes really important for us to have those things up and operational as quickly as possible so the fleet can deploy. And we've leveraged Coastal Trident for some of those technologies, whether it's giving technology to divers who have to quickly assess these type of facilities, whether it's in peacetime or an event happened, both natural or rogue. Being able to quickly assess and be able to repair that is really key for us. And then up to expeditionary, we play a lot in that realm. The first one right there is mobile utility support equipment. Right now, our MUWC, our CBs are deployed worldwide in peacetime operations, dealing with humanitarian assistance and disaster relief. And so we don't have to look too far with what's going on with several of the hurricanes. They're out there right now, not only with their assets, but helping other local communities and Navy and Marine Corps activities get power in place. And I'll tell you, the same thing is with water. Water is also a precious commodity, but that's just some examples of the expeditionary domain. The last thing I'll talk about up there is you can see the PIER JCTD. That's port improvement via expeditious repair. And that is a really important thing when it comes to port damage repair, being able to open ports. It's us in the Army Corps who does that for all of DoD. So right now, just in peacetime operations, we're also looking at how we help that. But in a situation when the balloon goes up, being able to use those assets to be able to load and unload, personnel and equipment wherever we're at, as far forward as possible, is pretty key. So that's just a good example. And then finally, moving up to the top, that's our life cycle perspective. So we do it from science and technology, research, development, testing, and evaluation, all the way to procuring it, delivering it, and doing the in-service engineering. So pretty much like most warfare centers, as Captain Hoffman talked about, that full life cycle perspective. The last thing I really want to end on here is some of the tools we do. Mention the Economic Development Collaborative. I know I put center there, the spelling error, but these type of tools, which we call non-FAR tools, is really a good opportunity for us to work together to be able to look at technology, test it, prove it, and find a way to deploy it. And we've had some very good success leveraging Coastal Trident, doing that along with other ones. So, again, a shout out as we look at, really together, everyone accomplishes more. That team type, it's a little bit corny, but it's true. It's really important as we reach out, not just to our own sister warfare centers, but also industry and academia. That diversity of solutions is key for us to be innovative, to be agile, and deliver those products and services to the warfighter as quickly as possible. All right, I was able to do it. Next slide. So now I'm going to get into talking a little bit about our requirements. I'm first going to start with our expeditionary domain. Got a couple acronyms up there: DMO, Distributed Maritime Operations, and EAVO, Expeditionary Advanced Base Operations. When you look at the CNO navigation plan 2021, it actually calls out aspects of this and what they call the 5 R's, from repair to revive to refuel to rearm to resupply. It's pretty key. As we look at what we need to do, it's not just going to be the first encounter that we have with an adversary, but how to quickly recover and sustain. And so the expeditionary community is going to be called heavily upon that, whether it's the Naval Expeditionary Combat Command, the Marine Corps, or the other services. And key things really is the enablers is keeping that infrastructure operable so that we can move stuff. And it's not just in our CONUS and OCONUS activities. These are with our allies and other places that we normally don't operate. So it's going to be very key for us to be able to do these things. And it's more than just what I'd say the infrastructure, but enabling that fuel and that movement of stuff is going to be really key. And the challenge really is we're talking austere environments. We're talking limited intra-theater availability of transport. It's going to be competition for that. So being able to move agile, quickly, expeditiously is going to be extremely important because there's going to be a lot of constraints. The other thing I'll talk a little bit about too from technology is being able to survey and inspect and get that information as quickly as possible. We're going to be in a contested environment, and competition to bandwidth is going to be extremely important. So having tools and technology that allows us to quickly assess, do the analytics, and make a decision as far forward as possible is going to be key. And it's not just in the expeditionary realm. I'll tell you, that's also for shore and oceans. We have the same issue as well. So some of our needs and innovative technologies that we're looking for, enhance speed and accuracy of remote surveying operations. And again, this applies like in humanitarian assistance and disaster relief. When something goes up, we quickly need to assess and be able to find out what has occurred, what has changed, what we can repair quickly, or what needs a lot longer solution approach from construction. And so in the expeditionary realm, we're not only looking at that, but we're looking at these where it's only dirt. But we need to figure out, can we put an expeditionary runway there for a UAS or for another asset? So being able to quickly assess that with information that exists and on the spot information, whether we're using LiDAR, GPS, or other type of tools and technologies, we need to quickly be able to get that situational picture so that we know what we can do, and then more importantly, what things we need to bring to bear to be able to build that capability. So again, that's not just the using an autonomous platform, but it's the sensors on it, it's the sense making to analyzing an information and quickly making a decision. So that's definitely an area that we look forward to having further conversations on. Enhancing speed, efficiency, and durability of construction operations. We're going to be tasked to be managing multiple things simultaneous, whether it's at one specific advanced naval base or EAVO or several within the theater. So having equipment that is semi-autonomous or reliable is going to be really key, because we're not going to have a lot of folks and a lot of equipment to do things. So being able to enable a hybrid approach of both manned and unmanned from construction operations is going to be really key. Also, the next one, enabling the use of in situ materials for high performance applications. Repairing airfields and piers isn't just an easy thing. And the problem is bringing all that material becomes very costly, heavy, and it doesn't meet our timeline. Just imagine trying to bring rebar and all the materials to make concrete, such as cement, aggregate, sand, and other materials. It's not quick enough, and it's not meeting our challenges. So being able to know what's in country using in situ materials, and also having good technology, a binder that can use local aggregate so that we can get those performance specifications. And the other thing too is when we're really talking about using that as far forward as possible, we're not talking days, we're talking being able to do this in hours and start using that asset as quickly as possible. And then lastly, enhance reliability, availability, and maintainability of expeditionary equipment. Again, it's going to be key for us. We're not going to be able to have leverage our EMC here locally. We're going to need equipment that works in multiple conditions, whether it's in desert conditions, cold conditions. And I bring that up because with the Arctic opening up due to warming, there's a lot more activity up in that area. And so our equipment that we need to deploy really truly needs to be all environmental. So anyways, that's expeditionary. And then the last I'll finish up with is our ocean and shore domains. So I talked climate change, also known as climate crisis. We've been dealing with a lot of these issues for several years. High level watermarks, breaking 100-year watermarks in the span of 10 years, like 5 or 6 times. This puts an impact on critical infrastructure, such as dry docks, such as piers. So right now we're dealing with a lot of humanitarian assistance and disaster recovery. So climate change is a big deal for us. And there's 2 areas I want to talk about, both energy and climate resilience and facilities and infrastructure resilience. So from an energy standpoint, we look at a lot of different technologies, from renewables to storage to other things, but really being able to take an installation or a particular unit and be able to have them operate autonomously off the grid, not for hours, but for days, is where we need to go. So we can do it for hours, but it gets a lot more challenging when you do days. So we're interested in discussing those things as well. And then the facilities and infrastructure resilience. We know a lot more energy is being applied to our infrastructure. So how do we build things that can not only withstand that, but how do we quickly assess and recover? So that's going to be a key thing as we go forward. I talked a little bit about cyber and facility related control systems. Here's some very specific things we're talking. We have quite a few different assets that are extremely important, and they range from SCADA systems and being able to transition them into a cyber safe environment. One of the things we really want to get to is automating incident cyber intrusion response via artificial intelligence or machine learning. It's going to be key. We have a lot of systems with a lot of data. How can we quickly know that we have an issue and quickly respond? We need to get to be responding within minutes and hours versus days, weeks, and months. So, you know, again, talking about what happened, you know, outside DOD, it's happening now. And our ability to be able to respond quickly is key. Also, plug and play tamper detection solutions for industrial control system devices, key for us. Again, we want to know if an incident did happen, being able to figure out what it happened and how to quickly clean it up and move forward. And then just really a lot of creating a library, really getting to the digital realm. A lot of data, we're doing a lot of modeling and simulation, but how do we make sure that we can share models that people create and put it in an environment so that can respond quicker? And the last thing I'll wrap up with is waterfront. Unmanned inspection surveys for specialized inspections. I already talked briefly about this in the expeditionary environment, but we're doing this every day. We inspect, my command inspects hundreds of critical facilities worldwide every year. So being able to do this autonomously and taking advantage of the technology is key for us. And what's happening too is it's not just the day-to-day periodic inspections, 3 to 5 years, depending upon what it is, but we are being called to inspect more because of damage caused by extreme weather. So this is an area we want to continue to push the envelope on. And then lastly, high performing materials. And this really applies again to all domains. You know, we build something, we want infrastructure that not only can withstand and enable operations, but minimize the amount of maintenance and repair we need to do. So pretty key on these materials, not just for the shore, but across all domains. And I probably went a little further than 15 minutes, but just want to say thank you for the opportunity to share these technology requirements and gaps we have. And tomorrow there'll be a few of us here, and I look forward to engaging with you and talking about potential solutions. So thank you. Back to you, Brendan.
Thank you, sir. Appreciate the insight from NAVFAC EXWC and your partnership in the ANTX-Coastal Trident program. So hopefully after our first brief, you get a little bit of taste of kind of what we're trying to do here. We're trying to match the needs of the people who are going to be using technology with the technologies that all of you in the virtual world are developing, with the expectation that these are going to become part of collaborative engagements, projects, technology transition that are going to serve our warfighters and our operational users out in the port and maritime domains. So we've got a few more briefs to come that will give you further insight into different areas of these domains and the port and maritime security problems, both on the Navy side and the interagency partners from state and local and non-DoD federal government. So next up is Mr. J. Cavalieri from NUWC, the Naval Undersea Warfare Center, Keyport detachment in San Diego.
Hi, good morning. Thank you very much for being here. Thank you, Brendan and Alan, for inviting me. I'm a huge fan of Coastal Trident. I think I've been supporting this with my branch and the little assets I have down in San Diego for the past couple of years. We host some of the events that we have in the past at our lab down there. So I think that the Coastal Trident and the whole ANTX and what this place does is phenomenal. I use it to groom and train my younger engineers on some small projects, let them pick out some things that they want to go after and let them go fail or succeed. And my guys, they hate me for it, but they love me for it at the end of it. So I think I'm a big fan of this. So today I want to talk a little bit about what Keyport does and what we're looking for. All right, so NUWC Division Keyport. So we're located, my mothership is located up in Keyport, Washington. We are primarily the in-service engineering agent for all underwater vehicles, to include torpedoes, soon to be Orca, Mark 30s, the ASW targets, and a whole slew of other UUVs. Really what that is, it's all about readiness, maintenance, and improvement. If you think about it, it's the big part of the cost for the acquisition cost for a program is the operations and sustainment. Well, when the companies, like for example, our Mark 30 program, the last was built in 1992. We've still been using these targets for submarine training for the last 30 years. No one's made them. So how do I make these parts? How do I keep these things still working when there's no replacement yet? So that's a big challenge that all in-service engineering agents have. Port Hueneme has the same challenge. They're above the water. We do everything kind of below the water. We also do operations for all the unmanned vehicles, especially in San Diego. That's a big group. That's a big function of what I do. I probably turn 130 targets a year supporting training for air crews and ships crews. We also do underwater testing evaluation. Again, the torpedo targets up in, or the torpedoes up in Keyport is the lion's share of what we do. And it's all about making sure those things go boom when they need to go boom. We're also jumping into additive manufacturing. Keyport has a phenomenal ability to make products. We've been making stuff for years when the contracts have run out. And obsolescence management. Again, back to that, if companies are out of business, they're not making the parts anymore. How do I continue to keep those things working? So what are we looking to solve? So we're looking to integrate some of our current sensor development at a system level. Right now, we're doing kind of one-offs. Our goal would be to kind of bring these together. Threat emulation. This is a big deal. If I want to work on improving my torpedoes or improving my targets, what's the threat going to be? So we have some classified programs that work at generating new types of threats. Underwater tracking, a big deal for us. We run all the ranges in the Pac Northwest. The ability to track a target without using an onboard pinger, or passive tracking is sort of where we need to go, both on the range and then off the range as well. So these are hard problems to solve underwater. That's what we're looking to solve. Data science challenges. Okay, you know, anytime we can do automation in our technical business side is important. If we're spending 300 or 400 man hours tracking down a part, that doesn't help me anymore. If we're spending 300 or 400 man hours, you know, trying to get through a certain buying process, that doesn't help anybody. The business data analysis and visualization is extremely important to us, especially as we move in towards the digital twin. And then the model-based product support for data analysis and integration with the model-based system engineering. Again, the system engineering that we do, it is going to rely a lot on this modeling-based science. Modeling and simulation challenges. Again, we want to do we do a lot of prototyping, and we want to demonstrate autonomy in our T&E. We want to demonstrate sort of a hardware in loop in the live T&E pipeline. If I could have a simulated target that sits with a real target on a range, now I can perceive to have 2 targets on the range for half the cost. That's the theory. It's a lot harder to do than it is to talk about. One of the things that we're working towards is the digital twins and the virtualized test set. And again, always mission analysis. One part of what my group does in San Diego is when the sailors are out training, we do post runs, we do post analysis on their torpedo shots, on their detections, their firing. So that's really important as part of a training program that we get something within our modeling ability. Cybersecurity challenges, everybody is doing this. One of the things that occurred to me that, you know, if the reliability of a fire pump is hacked or the data is manipulated, and now all of a sudden the fire pump has to be or has maintenance every 2 weeks, then the ship won't be operational. So we have this huge challenge of all of our subcontractors that make these parts and the reliability data that goes with this. It is important for us at the end of that acquisition tail to make sure that we have a good data within there, make sure those reliability and maintenance plans that we have set up for the ships and the systems are accurate, or else we'll be spending money on doing things we don't really need to do. So some internal investments that we're doing here at Keyport, again, the hybrid modeling and sims. My group specifically is working on these hybrid mobile vehicles. Krill is a tiny, tiny UUV. It's probably no bigger than a shoebox and a half. It's something we've developed. It's something we're working on, trying to develop that one to work. It's using additive manufacturing with our large format 3D printers to make. So it's an in-house project that we're trying to do. And then once we get 1 built and 2 built and 3 built, if they can all talk to each other, that's going to be the challenge. The next, I also want to use Riptide, which is a larger titanium hull. We're going to try different batteries. We're going to try different mechanical systems to see if we can convert this tiny krill into a larger, longer range type vehicle. Underwater optical comms. The 2 programs above it are going to rely exclusively on the ability to talk to each other underwater without using sound. Sound's a low bandwidth. Optical comms, we're doing some work with some other companies, and we're looking for other solutions to do high bandwidth underwater optical comms that is low detectable. The other thing that my group is doing is a multispectral imaging during additive manufacturing. So when the print's being done, I'm actually scanning with a terahertz system, and I'm able to see defects in that as we're printing and make corrections as we're printing. Kind of cool, very interesting. Again, the theory is there. We're still working out the details on that one. But the nice thing about that one is now I can print from any printer in any place in the world and make that part identically. So that's one of the cool things we think we can bring to fruition of that in a couple of years. Where do we want to go? Well, I always want to tighten the connection between our investment programs to meet the strategic goals. A lot of times we have programs that are here and here and here, and they're not really pulling in line where we need to go. So we need to tighten that group up. Additional granularity with our technical focus, with our sensors, especially our underwater sensors and our range sensors and our tracking sensors, is extremely important to us. Data science. It's something I think that we have fought for a long time, but we see the writing on the wall, and understanding and manipulating the data and getting our arms around that one, instead of just turning wrenches, kind of looking those and doing true math and science going forward and analyzing those. It's certainly really important to us. Modeling simulation, again, a big part of that. It's a nice cost savings for us as taxpayers, and I think we can get better results out of that. And cyber, everyone's talking about cyber, but I think this is we've all seen it. This is something that we all really need to invest heavily in going forward. And subject to your questions, that concludes my presentation. Thank you very much.
Thank you, Jay. And again, I apologize that we're not able to address questions in this format. There's a challenging lack of feedback for us as speakers, and we just don't have the ability to monitor chat. So rest assured, again, go ahead and put questions into chat. We're monitoring that. We will have our team take those on board and follow up with the speakers afterwards. So again, thanks for your flexibility and for your patience there. Okay, we're going to move on. We have Mr. Andy Corzine, the Chief Technology Officer from Naval Air Warfare Center Weapons Division here in Point Mugu. Mr. Corzine is online. So, sir, we're going to be presenting your slides from this side. We'll be tracking the audio, so please let us know when you'd like us to switch to the next slide. Over to you, sir.
Sounds very good. Can you hear me?
Yes, we can. Thank you.
Excellent, outstanding. Well, I appreciate that, and I appreciate the opportunity and the flexibility to be able to do this in a virtual environment, but I also look forward to being there in person tomorrow and getting to meet some of you and talk about some future opportunities. So I'll talk briefly this morning about the Naval Air Warfare Center Weapons Division. We are a full spectrum research, development, acquisition, test, and evaluation command, and subordinate command to the Naval Air Systems Command. As Brendan said, I'm the CTO here at NUWC at both China Lake and Point Mugu, California. In our mission, we've kind of aligned our principal functions into 3 primary pillars. Categories of work you might consider, the first of which is targeting and kinetic effects. So think things like weapon systems, both air and surface launch weapon systems, and the targeting of those systems. The next pillar is our air wing integration and interoperability and electronic warfare. So think some of those non-kinetic effects and the integration of all those capabilities onto naval platforms such as F-18s, F-35s, and then a third pillar, kind of the other cats and dogs of advanced concepts, prototyping, and experimentation. And of course, that's where we do a lot of our participation in things like ANTXs. And organizationally, as the CTO, that's where I align a lot of my work. But of course, we support that broad spectrum of RDT&E across those areas. And this morning, I'll just briefly touch on some of the S&T framework that supports all of that and our goals. So if you can go ahead and go to the next slide, please. Fundamentally, our guideposts which dictate the direction that we take with our investments and our capabilities and efforts. Start at the very top, of course, with our National Defense Strategy, flowing down through this year's CNO NAV plan and a number of additional strategic level documents. But then we also partner that with the focus that we are getting from our warfighters, particularly because of our mission. We start off with that carrier strike group and that air wing of the future and identify their capability gaps. And our job is to operationalize technologies we are developing to turn those into warfighting capabilities to help make them more lethal and more survivable. And here momentarily, I'll talk a little more about how we do that synthesis from the gaps down into our technical investment areas. Okay, next slide, please. So fundamentally, we start off with those needs and capability gaps, but then we have to overlay that with our mission and our skills, knowledge, and capabilities as well, and find that optimal blend that ultimately ends up in that warfighting capability. And so we do a lot of investment, and I'll talk about that shortly, internally in making sure that we're operationalizing those technologies. But we also recognize that we can't nearly cover all those needs just internally, both with funding or with personnel resources. And so that's where we look to other organizations and groups to partner with like this to be able to do experimentation, to do development, and really partner for externally resourced projects to meet our needs. We've got a lot of infrastructure in place, but we know we don't have all of that, and so we're looking to partner for both people, stuff, and funding to ultimately provide some capabilities in our different areas of focus. Okay, next. So in our strategy, we have to consider a number of things on how we can more quickly provide capabilities out to the warfighter. By the very nature of it in S&T, we're typically 5+ years out on when we're delivering capabilities. In fact, I often look in 3 timeframes, 5, 10, and 20 years out when we look at when we actually may transition technologies. But contrary to that, when we look at the carrier strike group composition and the air wing of the future and the capabilities they need and how the acquisition process was normally deliver things to the program of records, those don't all match up real neatly. We're often asked to address the so-called fight tonight. What can we deliver in the next 12 to 24 months? So our process is to deliver this rich menu of technological options so that the program of records and the emergent needs of the fleet can be addressed when they're actually needed. And so we try to get in front of that by understanding the needs as early as possible so that we can create these so-called shovel-ready projects so that when that's needed, we are able to quickly transition technologies into something that we can deliver at least as an early operational capability. In doing so, of course, our core work in S&T is to actually work the core technologies, and we do a lot of that in-house, but we also, again, need to partner with other organizations to bring along the maturity of those technologies. But in parallel to that, we recognize there's some complementary aspects, and so we leverage the Naval Innovative Science and Engineering funding to invest in a wide portfolio ranging from basic and applied research through technology transition. And in our basic and applied research, we have a lot of PhD level folks in some of the basic sciences of chemistry and physics, computational sciences, and then we apply those to some of the technology areas that I'll get to in here just a couple of slides. Excuse me. But in addition to that, we work very closely with transitioning the technologies and trying to mature those from basic and applied research into applied technologies and actually technology demonstration and transition. But to do that, we also recognize that we have to invest in S&T related workforce development because, again, it's only as good as the people we've got to do that work, as well as S&T related recapitalization and revitalization of our technical infrastructure. We've got to give our folks the tools and the equipment to be able to work in some of these technology areas. And so now fundamentally, what I'm going to walk through in the next slide is what we call our technology needs forecast. And that's really how we distill things from the fleet's needs down to the areas that we invest. Next, please. So happy to spend much more time with you tomorrow or in a future engagement to talk through each one of these processes, but I'll go through it quickly in the interest of time. We start off in our tech needs forecast process. Again, we start fundamentally with the future carrier strike group composition and what the fleet is telling us its priorities are and its future needs are. But we also work very closely with our in-house mission engineering and analysis department, who go through our particular mission threads of interest. So typically we look at things like SUW, surface warfare, and strike missions, and they will do in the classified environment very detailed integrated mission threads, and from those mission threads deliver those capability gaps for those capabilities that the fleet says it needs to do, not just for individual weapon systems, but across an entire mission thread, how all those pieces come together and integrate and interoperate. And from that, we then take the next step and flow those capability gaps into something we call heat maps. And that's where we start to look at all the different technology areas in which we normally have both, again, an interest and capacity for and meet some needs. And so we have a whole host of technology areas. We can start off with something broad like energetics as an example. And then from energetics, we flow that down into the next level of indenture. And we say, okay, well, that includes ordnance, that includes warheads, that includes propulsion, that includes energetic materials. And then within that, from propulsion, we may say that flows down into solid rocket motors and air breathers. And so from that, we get this kind of bar graph that you see on the chart there for heat maps. And across all those areas, we go out and we talk to the different program offices and projects, and we make an assessment of what impacts technological advances in each of those technical areas would make. And those could be, again, at the mission level. Does it have a real impact at the mission level, or does it have a direct impact to a specific program in terms of capability or schedule or cost? Can we provide a better capability? Can we bring that left and bring it sooner or more affordable if we're able to advance a technology? And that helps us prioritize where we might make some investments. And then we go to that next level of these gotcha charts. Gotcha charts are where we establish our technology goals, objectives, technology challenges, and actions that we can take on any one of those given areas. So then we can break it down into a subsystem level, and we can put together a plan for how we actually establish the technology challenges that are going to advance things to provide some of those desired effects that we've identified in the heat maps. And then one level even more detailed than that, we take a fishbone chart and we work together with the programs and our technologists to flow a timeline that says, if we make this investment in this capability and we make this much progress, we can now insert into this program record at this point. So again, we try to take that to the next level, which integrates at the NAVAIR level with our systems command with these shovel-ready projects. If we can show that we develop the technologies to the point where they're shovel-ready for at least an early operational capability, we can work then formally with the programs through NAVAIR to figure out different milestones and where we might do that, as well as help us identify some of those external partners for taking on that next transition for demonstrations and experimentation, and working with a lot of the sponsors to actually make that final leap to an operational capability. Next chart, please. So real briefly, just that, again, the flight plan is really how we take the highest priority needs. So once we've got shovel-ready projects, how do we take those off the shelf and turn those into something useful in the next 12 to 24 months, ultimately? And I'm not going to spend too much more time on this slide. We can go ahead and go to the next one. So kind of the last three charts, bottom line, and then get off the stage. For fiscal year 22, we have established that, again, that blend of where we see warfighting needs with what our warfare center capabilities are, and establish these 5 imperatives. And our goal is to advance technologies that support these imperatives as quickly as possible. So we are specifically developing for integrated fires an integrated fires lab in-house, but part of that is also to be able to link in with other capabilities that can address these so-called lightning charts. We are looking at real-world scenarios where we have all sensors, all shooters, trying to have the ultimate best effect again at that mission level by integrating it together, and to be able to do that in a live virtual constructive environment. And so that's a lot of the focus of that integrated fires lab. Long range fires and improved lethality, because we've got to outstick the competition. They have a lot of range that we have to overcome, and so to be able to go further faster, and that's where you'll see things like initiatives in hypersonics that we'll get to. Next generation EW for electronic maneuver warfare. Go ahead, and you can go back one slide still. Sorry. So next gen EW, we need to own the spectrum and be agile in the spectrum. We need to work across the different EW areas of electronic attack, electronic protect, electronic surveillance, electronic support. And we need to be able to take technologies both in an offensive and defensive manner across the spectrum, and we have a lot of investment in those areas. Unmanned systems, I know a lot of you are familiar with that. We primarily deal with that in the air domain, and a lot of manned-unmanned teaming, and how we can advance AI to promote that manned-unmanned teaming and help keep our warfighters safe. And then finally, air wing integration and interoperability. Again, going back to that air wing of the future, how do we not just make one weapon system? How do we not just make one weapon system integrate with a platform? How do we make that whole air wing work together? And how do we make that air wing integrated and interoperable with the rest of the carrier strike group and the joint forces as well? And so a lot of technologies for making that happen. Of course, the backbone of all that is having a good network that you can rely upon. So assured communications, resilient communications are areas that we're very heavily interested in. And next slide. And I think this is the last one. To give you a taste of some of the initiatives we are working on now and moving forward to focusing on in the future. I won't read them all to you, but you'll recognize the things as aligning with, again, back to the way we're aligned with our pillars, with things like targeting and kinetic effects with our mission, but also as we have worked with our mission engineers and the fleet to understand the capability gaps for missions like surface warfare and strike. All those things that go along with them. Of course, a lot of these are integral to each other as well. When we go out on a SUW mission, we're not just figuring out how to attack a surface vessel with a kinetic weapon. We're also doing a lot of electromagnetic maneuver warfare. We're also in both the support role and the defeat role. We are often looking at scenarios where we are taking unmanned systems and partnering them with our manned systems. So a lot of these things are really integral together for, again, that bigger picture on how we would actually execute a complete mission thread. So you'll see a lot of the things I've mentioned previously. When you read things like artificial intelligence, machine learning, cyber, quantum technologies, again, the key for us are, what's the trade space where we can add value and we can help close gaps. So, for instance, in quantum technologies, we're probably not going to invest a lot in quantum computing because there's a lot of industry out there to do quantum computing. Is it something we'll leverage? Absolutely, but probably not our core skill set to advance quantum computing, or for lower space, higher computing, lower power. Absolutely, we'll use those now. But you look at things like quantum sensing, so we can add resolution to our seekers and whatnot. absolutely that's of critical interest to it. And so we would be investing in that type of quantum application. Same thing with cyber AI ML. You know, there's a lot of work in there. We're not going to go do cyber defense of PCs. Now, maybe we're more interested in things like anti-tamper for our warfare systems. So again, tailor each of these areas to our mission threads, our capabilities, and those are the kind of technical areas that we want to develop in-house and partner with you all and others to advance those technologies, make them shovel ready so that we can deliver operational capability to the warfighter. And with that, I'd say I'll take questions, but I know that's not afforded in the forum we've got, but I'm looking forward to being there tomorrow, meeting with some of you and advancing the conversation to the next level. And I want to thank you again for the opportunity.
Excellent. Thank you so much, sir. Appreciate the insight from the air side, and look forward to further collaboration with you in Antex and Coastal Trident moving forward. Thank you. Our next speaker is Mr. Todd Getz, coming to us from the Office of the Chief of Naval Operations, OPNAV N57. He's going to give us some insight on the Navy's non-lethal effects priorities.
Morning, and thank you for the invite. This has been my first time at Antex, and I'm excited to see what is out there and listen to ideas if anyone has any. So OPNAV N95 and PMS 408, our program overview, we cover EOD, EOD underwater, crew, and afloat, anti-terrorism afloat projects. So as you can see on this slide, the J crew, identity dominance, fuse disassembly, but on the other side are the afloat, body armor equipment, visual augmentation systems, and our NNLE, which is long range ocular interruption, dazzlers, acoustic hailing devices, and IDS. NNLE and ATA programs. The sponsors are OPNAV N83, N95, which covers NNLE for the Navy, N96 for ATA related, and N98 for ATA related. Our shore and float missions, these are our overarching anti-terrorism and force protection. There are a variety of submissions that go under these two categories, so it isn't just two specific missions. Our ACAT programs, identity dominance, ACAT 4T, and the Maritime Vessel Stopper, which is a pre-ACAT 3 program. Our non-ACAT programs, allowance equipage listas, table of allowance items, visual augmentation systems, and then NNLE. Visual hail, warn, and suppress. LROI capability development document, we are currently awaiting our final approval. We are scheduled to go before the Navy Capabilities Board. The specifications that are in the CDD are a hailing range of 100 meters to 2,000 meters. Our suppress range, which suppress is a controlled precise action to induce the contact to terminate its approach, either by disrupting his ability, the pilot's ability to operate the vessel, or make it so painful that they're going to turn away. Sighting capabilities to maintain a laser on target a minimum of 1,500 meters. Now, with all of these lasers, we do want to maintain safe power output. We do not want to exceed NOHD, which is a non-ocular hazard distance. An adjustable beam size, the ability to be mounted on crew served weapons, and ideally we would like it to weigh 7.5 pounds or lighter. This needs to be a man portable, single man portable item. Audible hail and warning. The Navy accepted the U.S. Army acoustic hailing device CPD this past July. Some of the specifications: project sound and an understandable message to a distance of 1,500 meters. We would like it to project a signal which causes people to cover their ears, painful to them, in order to a distance of 1,000 meters. Now, we've decided to go with this CPD because the Navy's current inventory of acoustic hailing devices are obsolete, very antiquated. Many of them were fielded 15 to 18 years ago as a result of a nuance. So these next generation acoustic hailing devices, we'd like them to be one-person portable, easy setup to operate, the ability to use pre-record simplified messages, and have a safe zone, which is very important, behind where an operator or others within 180 degrees of the system can do normal comms, radio communications. Vessel slowing and stopping. The MVS capability development document was approved in June of 2017. The system, the requirements for this system is to deliver measures to affect propulsion mechanical workings of a vessel or contact of interest and stop its advance toward an HVU, high value unit, high value asset. The system needs to achieve an immediate target response and needs to have reversible effects, be able to be correctable on site, not at depot level maintenance. And we do not want this system to cause personal injury. Now, the goals in the CDD, successful engagement, whether it's a probability that it will take effect, entangle, occlude, or cause an engine stall. And to achieve MVS effectiveness, stop or significantly slow. Persistence is the duration of the effect, minimum period of time for the applied technology to remain effective. Now, all of these are spelled out in the CDD under the KPPs and KSAs. Material availability is another goal for us. As a percentage of total inventory of a system that is operationally capable. We do not expect the population density of these systems to be very high. We expect them to be low. At this point in time, they're going to be, when developed, we intend to send them to NECC. Operational availability. And then our next generation solution, which is where we need help. Production and assembly of synthetic slime, pass. We're attempting to utilize bio-inspired materials to enhance performance, specifically hagfish slime and spider silk. Now, for those who don't know, hagfish secretes a slime as a defense mechanism, and it swells to 10,000 times its original volume when it contacts seawater. Our scaled lab testing to date has shown that natural hagfish slime is effective to occlude a propeller. The slime has three primary components: intermediate filaments, mucin, and seawater. The IFs are currently being synthetically made via bacterial expression. And we are trying to determine if a similar material to this synthetic mucin can be made as a hybrid solution with a mimicking behavior. Utah State University has been assisting us with this, but they've gone as far as that they can. And we're currently evaluating concepts for payload delivery. This is something where we're looking for ideas from industry. How could we deliver this? How can we synthetically create the proteins needed to make this payload? Our NNLE capability gaps. These gaps were listed from 2 different ICDs and the Navy, i.e. U.S. Fleet Forces Command, PAC Fleet, NECC, and other echelon 2, 3, and 4 commands rank them. As you can see, the top 5 deal with vessel stopping. This is the problem the Navy has. The ones highlighted in blue are ones we're currently able to work on. You'd go down to 39, but the top 15 is really where we're looking, and the top 5 is where we really need a lot of help. Vessel stopping is a tricky capability to harness. Entanglement tends to damage the vessels, and if not retrieved properly, is a hazard to navigation. Directed energy is very short range and is nowhere near what we need in the CDD, which is why we've kind of started to look at occlusion more, proteins. How can we get the payload out there to meet the requirements in the CDD? That's the end of this brief. I'll be around tomorrow afternoon, all day, this afternoon. If you have ideas, I'm very willing to listen. Thank you.
Okay, thank you, Todd. Appreciate that insight. Hopefully you all appreciated the detail with which Mr. Getz spoke to their objectives and their priorities. Should be relatively simple to understand exactly what they're looking for. So definitely appreciate that insight. Our next brief is from the Department of Homeland Security's Science and Technology Directorate, Greg Wigton and Mr. John Rein. This is an important bit of insight for the ANTX and Coastal Trident programs, which work in the port and maritime domains. Typically, you might think of just us focusing on Navy capabilities, but the interagency partnerships that are associated with operations in the port and maritime domains are extremely important to the Navy, even though some of the capabilities that are necessary in that domain aren't necessarily maintained by the Navy. If you think of interagency drug interdiction or operations, littoral operations close to the coast, operations that are conducted in port, or the time that the Navy spends at the pier. The Navy doesn't always maintain the capabilities that are necessary to respond to incidents or interoperate with other organizations in those environments, in those cases. So the partnerships and the technologies and the capabilities that are shared with organizations like DHS and other federal government organizations are extremely important. So we're always happy to have the Department of Homeland Security through the Coast Guard, through Border Protection, and some of their other organizations, especially the Science and Technology Directorate, along for the ride for Coastal Trident. So our partners from DHS are going to give us some insight into what their programs are, how to engage with them, and what some of their technical priorities are. So Mr. Wigton, take it away, please.
Great, thank you. Everyone able to hear me okay? Okay, so my name is Greg Wigton. I'm the program liaison for the Office of Industry Partnerships with the Department of Homeland Security Science and Technology Directorate. The Office of Industry Partnerships works to identify how DHS can work with industry to find and acquire solutions for pressing R&D needs that are delivered to us by other DHS components. So as requirements come in, we work to identify the right people to do that work and provide those solutions. So today I'm going to talk a little bit about Office of Industry Partnerships and how we interact with industry to do that R&D and create those solutions. Next slide, please. Oh, sorry, that should have been my intro slide. Next slide. So for those of you that aren't aware, DHS S&T has a number of different mission areas to try and apply scientific, innovative approaches to deliver solutions for the entirety of DHS components. These gaps in these areas run from aviation to cybersecurity, infrastructure resilience, and so on. So we support CBP, Secret Service, CISA. Any number of the DHS components can identify requirements and submit those to DHS S&T for us to try to find solutions for. Next slide, please. So what I want to talk to you about today is the Office of Industry Partnerships and how we work to engage with industry and then deliver solutions back to our partners and even commercialize technologies for commercial use in the private sector. Next slide. So industry partnerships provides business opportunities for industry and different contract mechanisms and solicitation vehicles to help develop innovative technologies for Homeland Security. And then we do this through delivering these solutions through our mechanisms to provide mature solutions back to the DHS enterprise and to the private sector. Next slide. We do this through 6 main innovative programs that we have. Some of these terms may look familiar to you. We have a long-range broad agency announcement. That's an open existing solicitation that highlights very high-level gaps that we've gathered and allows industry and researchers to submit their proposals against that long-range BAA. We also run small business innovative research programs, which hopefully some of you are familiar with. These help small businesses apply for specific gaps that we feel can be filled by that community. And then some of our more unique programs are our prize competitions, which is essentially crowdsourcing to incentivize innovation. We essentially issue prizes to whoever comes up with the best solution or idea for a certain problem set. We do work with In-Q-Tel, which is really focused on the venture-backed commercial side of things. In-Q-Tel is similar to a VC, and they invest in technologies that are relevant to the government space. So we partner with them if we have aligning gaps. We also have our BIRD program, which is a co-international program with Israel. So that program, when we have projects, it usually has one U.S. performer as well as one Israeli performer. And again, these are to solve specific gaps that are relevant to both to DHS in the United States, as well as our partners in Israel. And then lastly, we have the Silicon Valley Innovation Program. This program is about 5 or 6 years old, and the goal is really to target kind of the innovation and venture communities, in the U.S., but also internationally. It's kind of a different approach. We can do very quick contracting through other transactions, and we do phased R&D efforts from anywhere from 3 to 6 months for each phase, up to 4 phases, with the idea of entrepreneurs who already have an existing roadmap or existing technology, and we try to identify how they can add capabilities to that to solve DHS problems. Next slide. So this slide, I hope, is really what's relevant for everyone here today. It kind of addresses what kind of what size, what kind of companies you may be, whether it's medium, large business, small business, academia, and so forth, and which programs best align to those organizations. All of these are a little bit different. As you can see, SVIP and SBIR are really focused on the small business entrepreneurs, whereas our long-range BAAs and prize competitions and things like that really are open to anyone. Each of these solicitations, when they go out, may have further eligibility requirements, so I do encourage you to look at those before applying or submitting a proposal for anything. But we are trying to reach, provide availability and opportunities for all sizes of industry and organizations that are out there. Next slide. So in addition to doing some stuff on the innovative side, where we're acquiring R&D and turning that R&D into solutions, the Office of Industry Partnerships also kind of helps on the back end too with technology transfer and commercialization. We do this through a number of different programs, and my colleague John Rein is going to talk about the Commercialization Accelerator program next. But we also work with develop CRADAs, or Cooperative Research and Development Agreements. So this is R&D between DHS and non-federal partners. A lot of these are where we have a specific technology or a specific performer in mind. We'll develop a CRADA with them to do that research. And then we also have something called Partnership Intermediary Agreements, where we work with organizations that are really advanced in their capabilities of technology transfer or transition and commercialization, and they can help us accelerate some of the R&D that we are doing internal at DHS. They can help accelerate that transition to private sector and commercialization. Next slide. So since 2 of us are briefing here in one slot, I went through those slides pretty quickly, but I did want to provide, I think that's probably the most important thing, is that top link right there on how to work with S&T. So if you go to that link, it'll have all the programs I just described, as well as a couple other that fall outside of Office of Industry Partnerships. But they should have links as well to current solicitations, current needs, and directions on how to apply and submit proposals towards those. And then we also have, S&T Innovation Inbox. This goes directly to our OIP division. So if you have any further questions, please feel free to shoot an email to that address, and we'll get back to you shortly. And with that, I'll hand it over to John to review his CAPT program.
Hi, everyone. I'm John Ryan, the program manager for the Commercialization Accelerator program. Happy to be talking with you today. Wish I was in beautiful California. I'm actually broadcasting from Alexandria, Virginia. I definitely want to thank the Port Hueneme leadership for their willingness to participate in the Commercialization Accelerator program and help us move naval innovations into deployment. I spent 18 years with NAWC Atlantic, and I joined DHS S&T in 2019 in their technology transfer and commercialization office within the same department that Greg just shared with us. I'd like to give you a little overview about CAPT. Next slide, please. CAPT is providing services and resources to advance federally funded technology into the marketplace. We're really trying to increase the opportunity for these innovations to really have an impact on government and the broader Homeland Security enterprise. As many of us know, a lot of R&D organizations do a great work. We have a vast amount of innovations, and just for a variety of reasons, many of those innovations never leave the laboratory. So CAPT is bringing together those existing federally funded innovations and the broad Homeland Security enterprise challenges to help accelerate technology maturation. So CAPT is collaborating with R&D organizations to help essentially alleviate the barriers for transferring relevant innovations and enable broad pathways to the marketplace and getting those innovations really into operational use. So we're also providing some commercialization assistance services to help advance the market readiness of the prototypes and increase the likelihood of adoption by an industry partner that can really create a product or service in the marketplace. So the overall focus of CAPT is really to enable a federally funded R&D technology to become available in the marketplace that can be adopted for use in the private sector as well as through government use and broader Homeland Security enterprise utilization. Next slide, please. Our CAP approach involves leveraging the previously developed R&D that may have been funded by DHS, but may have been completely funded by other federal entities. So the laboratories that we partnered with perform a self-assessment and identify candidate technologies within their portfolios that are at least technology readiness level 3. And they select these technologies and let us know if they're primed and ready for this process. So CAP then takes those technologies that are proposed by the labs and conducts a viability. Here is a high-level list of all the categories that CAP is interested in pursuing. So as you can see, it's a broad range that covers a large mission space. And we, of course, have the all-encompassing general category for those emerging technologies. And so what this list reflects is essentially the complex mission, any considerations when it comes to opportunities to really determine the viability of the technology as it relates to what's available in the marketplace and what the market might be looking for, both government and commercial. So the subject matter experts that help to develop the viability assessment also recommend project activities. And these project activities will help determine the task and timeline and resources that may be needed to advance the technology towards the marketplace. It really helps to inform the lab on what their project may look like and helps to build out those activities so that we're potentially making the right collaboration moves and bringing in the right stakeholders for these projects. Next slide, please. So here's a look at our current list of CAP performers that we partner with, including Port Hueneme. You may be familiar with a few of these, if not all of these organizations, and we're working with 6 DOE national labs, 2 FFRDCs, MIT Lincoln Laboratory, and MITRE. And on the top right, we have 5 DoD laboratories, actually 6, and Johns Hopkins University, New York Applied Physics Lab. So we're trying to paint a broad brush, get a lot of labs involved in this process. And I think we've got a really good cohort moving forward. And you'll see that, I think, in the next slide, please, here. So on this slide, this is our snapshot of CAP by the numbers. And the data that we have here in the blue reflects our results so far. And then our items in green are our planned items. So essentially, we've identified over 60 technologies across the performers that we just saw. And those technologies span a couple of different areas, but wanted to call out a few here with cybersecurity, chem bio, and critical infrastructure. We performed over 20 viability assessments. So we've informed the lab about the viability of a few of their technologies. And so we're making decisions on project advancements for a lot of those, and you'll see that in the next few slides. So we're investing between $25,000 and $250,000 per project. Some projects are a little more complex, but essentially we're trying to find the right fit, and like I said before, develop the project plan that's best suited to advance the technology towards the marketplace. So we've also conducted some innovation workshops with the technical personnel, just to make sure that they have the right framework for how to message their value proposition, the uniqueness of what they developed, and how to potentially deliver that message to various stakeholders. We also have a third-party software testing agent to help provide some insights into how labs may be able to refine their solution for ease of integration, as well as increase some security capabilities. Next slide, please. So here's a dashboard of the 25 CAPT projects that we have going on right now across these 13 different technology areas. On the left, from air security to sensors and platforms. So a few of these performers are working on multiple projects, but I think that CAPT has definitely a promising set of technologies in this first cohort, and I think it's going to help to really validate our approach to solution delivery and getting technology transfer results. Next slide, please. So I mentioned funding mostly for the prototype, but beyond that, we are providing some commercialization support. And here are a few of the services that those commercialization support providers can deliver to the laboratory personnel. We will, of course, provide some insight into sort of the market landscape and competition analysis, as well as evaluation of technology features, or potentially evaluating the design for manufacturing. We can also provide some testing support or validation support. But essentially, through the CAPT process, we really want to increase awareness of these capabilities to external stakeholders, so that we can potentially help them to realize the value that these R&D innovations can bring, and potentially create partnerships that will enable some sustainable businesses and incorporate the technology into their product or service offering in the marketplace. Next slide, please. So essentially, CAPT is increasing the ability of these R&D laboratory partners to really capitalize on their own portfolios. As we move forward with the CAPT process, we hope to enable partnerships between CAPT performers and private industry, really to increase utilization of federally funded R&D and lead towards a sustainable product or service in the marketplace. We work with the labs to help improve their abilities to essentially leverage more efficiently the R&D innovations that they already have. Maybe they've already protected them through the patent process, but really want to just enable a pathway focused on having this capability available to the government and the marketplace that can be supported throughout the life cycle. So what's next for CAPT? In our future plans coming up soon, we're working to establish an online proposal platform. And this will enable our R&D organizations to submit proposals and have those evaluated by our DHS personnel, and really hopefully provide an ability to develop pathways for more technologies. And moving forward, we'll also work to include a more broad base of R&D performers to make sure that we're leveraging as many of the innovations that are possibly available. And our next slide has the contact information, and really be interested in connecting with you all if you're aware of any innovations that may be ready for the CAPT process. And definitely thank you for your time today.
Thank you, gentlemen. Really appreciate that insight from Homeland Security S&T. If you're paying attention to those categories of interest that they're talking about, you can see very distinctly where the overlap is between and the synergy between Navy capabilities and the interagency partner capabilities, and why it's so important that we partner with organizations like Homeland Security in technology development, in innovation and interoperability capability development. So thank you, gentlemen. Appreciate that insight. Our next speaker is Whitney Tallarico from NavalX. She's going to talk about the capabilities of the Tech Bridge program and the consortiums that are associated with that, of which FathomWorks, which we are talking to you today from, and the open house tomorrow will be at the Ventura Tech Bridge. Whitney is the director of the Tech Bridge program, so she's going to give some insight into how to work with the Tech Bridge, what kind of capabilities the Tech Bridge is looking for, and how you can get engaged.
All right. So it's a lot of awesome information you're getting so far. I'm actually going to try to stand back here and be loud enough for everyone to hear. So please let us know if you're not hearing online, but I want to be loud enough to the audience who's here physically as well. So NavalX was started about 3 years ago by Hondo Gertz. He was the Assistant Secretary of the Navy for Research, Development, and Acquisitions at the time. Then he moved up to Undersecretary and is now no longer with us, but his vision was to create off-base facilities where we could share lessons learned and collaborate more effectively with industry and academia. This group here is obviously one of those spaces. We've been able to build bridges with industry, academia, and a lot of our naval stakeholders, as well as other DoD stakeholders. So, so it's been awesome just to see what kind of people are coming through. DHS, like the Department of Homeland Security, coming through to talk about their problems and opportunities. Folks maybe not here today, but AFWorks, OSC, other groups in the Department of Defense and other government agencies who want to work with you guys. Like, this is a great opportunity and a great front door to really find opportunities for your industry or academic partnerships. You know, we were not just founded to partner with industry and academia, we also were partnered with each other. So how do we find alignment? How do we find these areas where we have business growth accelerators, and we have them in the Department of Navy, and not everyone knows about them. They're in DHS. NSF has grants and opportunities through their SBIR portfolio, as well as other groups. So what we're trying to do is make it easier to work with us. Alan Yeager is the director here of the Ventura Tech Bridge. We have a number of them. I do encourage folks to go and look at the NavalX website and identify the NavalX Tech Bridge annual report. Fun fact, if you Google tech bridges, there's another organization with some women in STEM, separate organization, but looks good. So if you Google them, try adding NavalX to the front of it, and you'll be able to find our annual report. I just want to talk a little bit about the mission and vision. So reducing barriers of entry for non-traditional partners, still working with primes and other government organizations, but finding ways to get at new technology faster. A lot of what we do in Tech Bridges is really find ways to partner internally to make our opportunities more streamlined externally. So, you know, if there's a group that's really good with cyber at NUWC or NUWC Pacific, which are our warfare centers in Charleston, South Carolina, and in San Diego, we can add that to our data analytics capabilities in NSWC Corona in California. And we can tie in other partners as needed in our internal network, but also in our external networks for people who are already on contract with us, but we're not leveraging to their max potential. And then also for new folks who are developing technology in a lab or in a garage and don't necessarily know how to interact. So I'd encourage you to talk with folks like Diana Teal at the Central Florida Tech Bridge and otherwise. But this event is one of the exciting parts of opportunities. So when we go, we try to measure all of our programs and put them across an innovation pipeline. So we're saying, all right, this is where we source problems directly from the fleet. A number of folks today were talking about warfighter engagement. A lot of those curation sessions, we like to meet with end users and stakeholders at shipyards, Marines, sailors, and really figure out what's eating their lunch. Why are we not getting our missions completed as effectively as we could? And then we take those kind of problem sets and then we curate them, identify other stakeholders who might be working on these problems, and then do a scan to find out how other folks are solving these things today. You know, this is kind of a scanning event, but it's also a testing and evaluation event where we bring in awesome folks from across the board and we learn about what's possible. So I think it's a huge credit to this group, all the people who put this together, to have so many folks participating and saying, hey, I want to see where my technology fits in. I want to get feedback. And I want the folks in the Department of Navy and in other organizations to think through how my technology could meet a need or could show a new capability that we didn't know we needed. So these events, these collision events or testing and validation events, they really provide an opportunity for industry and academia to understand what our needs are and what we're really pushing for, but then also to hear from you guys on what's possible. Even in the Department of Navy, we're so distributed. that we don't always see what capabilities are ongoing. And the presentations we're hearing today, I'm taking notes left and right and asking people to start capturing these things so we can make them, like all the programming that is being offered at, the Keyport folks, the new Keyport folks, the folks here in the 3 warfare centers that are co-located, how do we start aligning those efforts and creating real opportunities to move things forward together? So that's really what we're about. We're maintaining this mission under the Office of Naval Research as well. So we're getting support directly from the Chief of Naval Research, as well as the Assistant Secretary of the Navy for Research, Development, and Acquisitions, Jay Stephanie. So phenomenal teaming going on internally across our network. Right now, that network extends from Hawaii to London. So there's 15 tech bridges now. All of them have different skill sets and opportunities and industrial bases that could have solutions to problems. We're trying to communicate more effectively to say, hey, I have a problem in this area. Do you know anybody on contract or an industry member who you just met at a conference who could help us? So we're trying to be that front door to welcome people in from the government side and our non-traditional partners in industry and academia to help make those connections. So in that way, we serve as a platform, but we also have a lot of technologists involved and integrated on our teams so that if we need that technical SME or expert to say, hey, I really like this idea, but this we've tried 100 times, it hasn't worked. Let me tell you why. Not no, don't do it. Not just we have tried it before and it failed, but here's why. So we're trying to make those really meaningful connections everywhere from STEM education to acquisitions. So really excited to see what comes of today. And I don't need to take up more time. If you guys have any questions, I'm happy to take them.
Thank you very much, Whitney. Just want to take a second to say that the engagement with the NavalX organization and the TechBridge community has been a really significant resource for ANTX and Coastal Trident for the past few years, and we're super happy to have them engaged and plugged in. They've been a tremendous resource for reaching out to technologies and getting technologies plugged into our program, but just kind of increasing our general awareness of what's going on out there, what the priorities are, and organizations that we should be able to plug into to greater increase our reach and our scope, and just the benefit that we're able to provide to the Navy and the interagency community of stakeholders. So thanks again to Whitney, to Alan for leading the Tech Bridge here in Ventura. Our next speaker is Troy Clark. He's the director of the Inland Empire Tech Bridge that exists at the Naval Surface Warfare Center in Corona. So he's going to give us some insight a little bit more into what an individual tech bridge brings to the table and is looking for as far as priorities, as well as what the priorities and the technical needs of the Surface Warfare Center in Corona are. So Mr. Clark, if you're online, please go ahead.
Yeah, thank you very much. Can I get an audio check? We good?
Yeah, you're great. Thank you.
Thanks for having us. It's a great event. Looking forward to being there tomorrow. One of the things I want to talk to you about is a little bit about our mission at NSWC Corona and how that plays into our tech bridge locally, and how it influences that. So with Anchor Command is Naval Surface Warfare Center Corona in Norco, California. Our mission really is to gauge the warfighting capability of the Navy and Marine Corps. So we do that by providing that transparency into warfighting readiness through 3 distinct sets of our mission. So one, we assess the Navy's performance and readiness. So we do it through data analytics and assessment. We also serve as the Navy and Marine Corps' measurement science and calibration technical agents. So we provide that transparency through measurement accuracy. And then we're the range systems engineering agent for the Navy and Marine Corps. So we provide that warfighting readiness through the fleet training live virtual constructive. And really, our vision is to use all that data analytics and that transparency to optimize decision-making for warfighting and fleet readiness. So we can advise our program offices and the fleet, how we're genuinely doing. Provide that ground truth to them. Let me do that. Okay, it's going to take a little bit of time to render. So where we are, so we're headquartered in Norco, but we've got detachments in Fallbrook and Seal Beach. But we are also embedded in the tactical training ranges all around the eastern seaboard as well as the west, and up at Top Gun Training Range in Fallon. So we've got a broad footprint. We've got about half of our folks in Norco. The other half are distributed at our sites. We were approaching about 3,800 people so far, with a mix of civilians and contractors. And we continue to grow based on demand for our mission to provide that transparency into warfighting and fleet readiness. Okay, so Whitney, you've heard a lot from other presenters this morning about the different warfare centers around the country. So we've got 16 within the Navy Marine Corps R&D across the surface, undersea, information, and expeditionary warfare domains. And you see also our naval labs are on there as well. And as federal laboratories, we're authorized to engage in tech transfer. So that really provides a lot of the capability to partner with those outside organizations and gives us that operational framework to really facilitate collaboration. So tech bridges are anchored to each one of those warfare centers. So you see the map here. We've got 4 in California and 3 in Southern California. And we work closely together with our partners at Ventura, and then SoCal and Central Coast as well. And then on the west is with both Hawaii and Northwest. We also collaborate from a geographic domain there in the Pacific. And so for the Inland Empire Tech Bridge, our vision really is to be the catalyst for our region to develop as a national innovation hub, and then be that big driver for technology-based economic development. And that's what helps bring those outside stakeholders to the table, because they see the value of leveraging the federal laboratory and the tech bridge to help facilitate economic development in their region, which just overall strengthens the innovation ecosystem around us and makes it even better. Leveraging on our mission set. So every tech bridge, as Whitney mentioned, every tech bridge has certain focus areas that's based off their anchor commands, mission areas. So for us, we're focused on data analytics and visualization, leveraging all the data that we have and the expertise that we have, and performance and readiness assessment. And then from our work with live virtual constructive training and managing that network for the Navy, focus on those networked data environments. And then from our expertise in the measurement science and calibration, focused on measurement technology. And so I want to talk about the development cycle, how your tech bridges get established, how they mature. We have, and then how they're ultimately sustained. So once you're launched, we really go through a connection phase, a reinforcement phase, and then that sustainment phase. And you'll see in the lower left, you'll see the our region, which is 2 counties, San Bernardino and Riverside counties, comprise the Inland Empire. San Bernardino County is the largest county in the country. Combined, that region is larger geographically than 10 states, and from a population standpoint, we're larger than 25 states. So we have a huge area to serve. And you'll notice how close we are to Ventura Tech Bridge and SoCal Tech Bridge. And also note that California has the largest number of military personnel of any state, and 81% reside in that Southern California map you see right there. And of all the military, 63% are sailors and Marines. So we're right smack dab in the middle of all that military personnel at NSWC Corona. We have 7 military installations in our region. So our base, March Air Reserve Base, Fort Irwin, Marine Corps Logistics Base, a little bit of Edwards Air Force Base, and China Lake as well. So we have a number of military commands that we can serve and partner with as we work collectively on joint problems, and then share knowledge where we can to help everybody go faster. We're in the kind of the reinforcement as we've been in the connecting phase, and I would say primarily, because of our geographic location is in Riverside County, we've got strong connections there. We're building our connections over onto the San Bernardino County side. And then as we start with our programming and establishing our facility, getting into the reinforcement phase, and working on different projects that you see there, like automated speech to text, quantum metrology, looking for partners to help commercialize that, and working with like the JAIC, Joint Artificial Intelligence Center, their Tradewind to help develop artificial intelligence prototypes, et cetera. So ultimately, each tech bridge needs to have a sustainable business model. So while the Navy provides some seed money to get us started, you have to work with your regional partners, and how do you create that sustainable business model to continue going. And then ultimately, you want to have that network that provides the problem solving and solution fielding, and that sustained technology transition, both spinning in technology and then spinning out technology for dual use pursuits for that technology-based economic development. You'll see in the bottom right, a lot of our key partners that are listed there. So we're partnered with every college and university in our region. So that's UC Riverside is the only top tier R1 research university, public research university in inland Southern California. Then our two California State universities, Cal State San Bernardino and then Cal Poly Pomona. We're also partnered with our private college universities as well. We have a number of them. You'll see like Cal Baptist, CBU there. And then all of our community colleges in the Inland Empire and Desert region. So there are about, I think, 11 to 13 altogether across 8 or 9 different community college districts. So that's really integral to connect us through the whole academic pipeline and then we're also connected with the in the K-12 space with the Science and Technology Education Partnership. So we have a comprehensive connection to the STEM pipeline, which is really going to provide the sustainment from an intellectual capital standpoint when you have your STEM professionals coming up through the pipeline. And then here's just an expanded network or expanded list of our network spanning both government, our business community, academia, and then various community boards. And I've got a brief later on this morning with another one of our congressmen from our region, Congressman Pete Aguilar's office, who's from the San Bernardino, Redlands, eastern part of the Inland Empire that I mentioned. And then, so what does success look like for us? So really, it's establishing that regional collision space so you can have us that low barrier of entry to partner with the Navy and Marine Corps for us to have easy access with our academic partners, local governments, our small businesses and startups, and the venture capital community. We would also want to see the increase of the SBIR awards to our regional companies to help kind of provide that spark of ideas to help mature them as they come through and develop the answering Navy and Marine Corps problems. And then looking for outside external grants and external funding to support and sustain those efforts. Success is really creating those new companies that you establish them, then they continue to develop and provide and thrive by providing services and products to both the Navy, Marine Corps, and the private sector. And then ultimately, TechBridge mission needs to be that dual use pursuit of technology. So you're spinning it in and you're spinning it out. And that really advances the Navy Marine Corps mission while it grows and matures your innovation ecosystem, which provides even greater capability in the future. So some of the key initiatives that we're working on are automatic speech recognition in tactical environments that turns out to be quite difficult, very noisy, very occupied with jargon and abbreviated commands. And then DevSecOps development, DevSecOps and cross-domain environments. That really helps us in our data analytics and our software programming capability. And then another important initiative is the ship maintenance data analytics and improvement initiative. So leveraging our data analytics capability and predictive maintenance, and then even taking that capability and integrating it with business in the business domains and business intelligence. And we're doing that with PEO ships. And then lastly, quantum metrology. We're working closely with the National Institute of Standards and Technology to really embed calibration, that it's linked to physical constants, so that calibration is embedded into test equipment. So while we could work with NIST to develop prototypes or concepts, that we're really going to need our commercial partners in industry to take that to market for us. And with that, I would look forward to being there tomorrow and talking with you as we look to see for opportunities to collaborate on those areas that I just discussed, and then anything else that we can go off and do great things together. So thanks for having us, and thanks to Alan and his team, Brendan, for coordinating this virtual summit today.
All right, thank you so much, Troy. I really appreciate that insight. Our next speaker is Dr. Kathleen Gilpin from Parallax Advanced Research, APEX, the Academic Partnership Engagement Experiment, which is a partnership with the Department of the Air Force for tech transfer and innovation. So you'll see, again, similar to Department of Homeland Security, Department of Air Force has also got some S&T tech transfer innovation programs and a unique community with significant overlap with the Navy. So Dr. Gilpin is going to talk to us about how her program supports the Air Force and opportunities for engagement with the Navy. Dr. Gilpin? Okay. I'm being told that Dr. Gilpin is not with us yet. So what we're going to do, we have scheduled a break from 10 o'clock to 10:30 Pacific time. we will reach out to Dr. Gilpin and try to get her back online. So we're going to go ahead and break now. It's now 9:25, but we will come back from our break 15 minutes early to support Dr. Gilpin's brief. So come back at 10:15 Pacific time. We'll put that up on a slide for you to so that that's clear. Go ahead and take some bio breaks. Go get lunch. We really appreciate you sitting through these briefs. One of our partners kind of took us aside today and said, "This is really interesting. Today is about content. Tomorrow is about contact." And that really rung true with me. We are, again, the reason that we're doing this in the format we are is so that we can reduce the opportunities for people to gather in large groups and really kind of take our COVID-19 mitigation serious. And that's the reason that we're going to be able to gather in person and have an in-person event tomorrow and really get back to this engagement, which is the key to this community. It's the feedback that we've gotten year after year as we do this event, is that the opportunities for people to engage and have contact is really what their benefit is for this open house event. So we're taking it seriously. Again, that's why this event is a little awkward today. It's kind of something we're trying for the first time, and I want to thank our support from NavalX for making this work. Been kind of looking at the participation over the course of the morning, and we haven't been losing people in droves. So I'm going to assume that means that we're at least doing okay. So again, I thank you for your patience, for your flexibility, for having a little bit of sense of adventure with us. So again, like I said, let's please come back at 10:15 Pacific time, and we'll kick it off with Dr. Gilpin's brief, and then we'll transition into Coastal Trident, start talking about ANTX and Coastal Trident, what those programs are, and get into some details of the projects that we've executed that are, starting to move us towards meeting the needs that our stakeholders this morning have been talking about. So again, the slide here says 10:45, but we're going to come back at 10:15, please. Again, appreciate all you collaborating with us, being patient with us, joining us here virtually. We'll see you at 10:15. If you do have any questions, feel free to reach out to me on my cell phone. You've all got my contact information. You can email us. You can put some questions in chat, and we'll be happy to get back with you. We'll see you all at 10:15. Thanks. Okay, it's 10:15 here on the West Coast. We're going to go ahead and re-engage, get our program started again. Thanks for everybody for hanging around, hanging with us. Before we get started with Dr. Gilpin's presentation, just want to say we've received quite a bit of feedback from by email and text of things that we're doing well, things that we really could improve. Just want to reiterate that we're doing this a little bit different than we've ever done it before. So all of that feedback is really appreciated. Keep it coming. Let us know how we can do it better next time, or how we can adjust on the fly to make it work better for you. But we are back. We're going to kick off the next part of the program. Our next speaker is Dr. Kathleen Gilpin. She's the Director of National Engagement at APEX, which again is the Advanced Partnership Engagement Experiment. That's a partnership with the Air Force for technology transition and innovation. Dr. Gilpin, if you're on the line, carry us away.
I am, yes, thank you so much. I am really excited to be here, and I am grateful for the opportunity. I'm looking forward to the continued collaboration between APEX and NavalX Ventura, because so far it's been great. So looking forward to keeping that going. Next slide, please. And next slide. So APEX is a partnership intermediary for the Department of the Air Force. We can go to the next slide, please. And as a partnership intermediary, our job is to collaborate with partners like universities and small businesses and academia, and to get them connected to the right person within the government, a government stakeholder. We do this most frequently through the SBIR STTR program, although there are other ways to do that as well. And our end goal, like yours, is to get the technology in the hands of the warfighter. And more than that even, is to get the right technology in the hands of the right warfighter. And it can be difficult because we understand you can't just pick up the phone and call the Air Force. And I know that you've probably heard a lot about the Navy this morning, and what I'm talking about is the Air Force. However, there are a lot of parallels, and I think you'll find that what I talk about is going to be interesting, because it is different and it is from the Air Force, but there are still a lot of similarities. So Next slide, please. Okay, this is the slide that we call the Apex journey. On the right, on the far left-hand side of the screen, you'll see the Outreach Express bus. This is simply making as many people aware of AFWERX's SBIR program as possible. But then once we get people excited and on board with the new things that the Air Force is doing, we offer a series of cohorts that you can join, and we call this process navigation. Now, we are funded by the Air Force, so obviously we focus on Air Force, but we are also capable of doing the same thing for the Navy SBIR STTR program as well. We offer SBIR training and actually a variety of different platforms, and I'll show you at the end of this presentation one of the platforms that you can do on your own time wherever you are to learn more about the SBIR phased program. And then eventually you'll have to cross a series of steep peaks and deep valleys, and we at Apex think that we can help you cross those mountains and those valleys easier. It's not necessarily always going to be a straight path, but it's certainly more straightforward than if you were to try to go it alone. And so, and we help with the valley of death that everybody is very fond of, I'm sure. So the ultimate goal, of course, is to win government and commercial programs. And this is great for small businesses and university entrepreneurs because it means you've sold or licensed your technology to the government. Next slide, please. So this is just an example of who we help. Of course, we help university entrepreneurs, R1s, R2s, and we outreach to vice presidents of research, as well as tech transfer offices and PIs. But we also help non-traditional universities, small businesses, economic development organizations, and any kind of state, regional, or local government organization that are set up to help small businesses. An example of this would be small business development centers, SBDCs, or we work closely with FAST programs. So things that are on the state level, but that are set up for the benefit of small businesses. So next slide, please. We are a national organization. You'll see on the next slide that we have quite a number of contacts from around the country. The left-hand side shows sampling of the universities that we've partnered with in the past. And then the right-hand side is some of the small businesses that we've partnered with. Our total number right now is much higher than what's shown on the screen. We have about 250 universities and 500 small businesses right now. But we're always looking to grow our network. So if what I talk about for the rest of the presentation, if you think that it could benefit you, by all means reach out. My contact information will be on the last slide. Next slide, please. Okay, so what I'm going to talk about now is some differences between the Air Force and the rest of the services. The Air Force has made it much more venture capital-like, and they've really shifted the paradigm. Instead of, from what I'm familiar with the Navy, they will have a standard list of topics that they want solved, or problems that they want solved, or topics they want researched. And they give that to you, you propose a solution, and then you're funded or you're not funded. The Air Force is different because they have said, what technology do you have that you think could solve a problem within the Air Force? It's very much open-ended. And the one thing that they are highlighting is faster contracting, and then they want to do smaller, more numerous awards. So they have different programs where they want to take small bets on a lot of different companies because they want the best and the brightest ideas, and they understand that maybe not every idea is the best and brightest idea, and so they are willing to fund a lot of opportunities with the knowledge that not every single opportunity is going to pan out. Next slide, please. So it is a phased program, and this is fairly similar across all the services, but I'm going to highlight just a few things that are different for the Air Force. Phase 1 is all about proving feasibility, and the award level is usually $50,000, and this is where the open topics really dominate. An open topic just means that you can pitch whatever your technology is, whatever your idea is, to the Air Force. And if you win a phase one, you've essentially been given $50,000 and 3 months to do customer discovery and find a government stakeholder. And this, if you're applying for an Air Force, it has to be an Air Force stakeholder. And this is where Apex can help, because we understand how difficult it is to, one, find a person in the Air Force that is interested in your technology, and then two, help them through the understanding of what an MOU is. We've run into countless problems with people not really understanding who can sign it, what they're signing, the fact that the MOU has no legal implications or anything like that. And so we have been helping some small business and university entrepreneurs wade through that swamp. Then for phase two, this is all about prototype and demonstration. Typically the awards are $750K for 12 months. And then you do have a direct to phase two capability. Then you can have either a sequential phase two award or what's called phase two plus, which are enhancements. This is unique to the Air Force. They're doing TACFI and STRATFI, and they can be multi-million-dollar awards. As we all know, there's always one more thing that you have to do to make your technology viable, or to do one more test on the technology before it's commercializable. And so this pot of money is for that. There are a lot of wickets you have to meet because it is such a large sum of money, but it is out there and it can be extraordinarily beneficial to the companies who really need it. And then finally, phase three, I mentioned before, this is the goal of everybody. It's technically by law, it's not SBIR money, but it is part of the program. And this is the goal, because this means you've achieved probably and hopefully a long-term customer within the government. Next slide, please. So this is what Apex can do for you. We offer one-on-one coaching or consulting and support throughout the process, for both before you even have a phase one, while you have a phase one, while you have a phase two, and then while you're trying to get a phase three. We offer different levels of support to all of those different categories, and we form cohorts a few times a year based on these different levels of award. And one of the things I would like to highlight is on the left-hand side of the screen, the team matchmaking. This is something that we started last year for Agility Prime, which was an out-of-cycle STTR. As it happens, there's another out-of-cycle STTR coming. It's supposed to be released any day, but nobody has a firm date yet. And it's going to be called Orbital Prime, and it's about cleaning up the space debris in low Earth orbit. So we can do matchmaking. If you're a small business looking for a university to do some high throughput testing or answer some theoretical questions, perhaps a university partner would be good for you, and we can do the matchmaking for that. And then alternatively, if you're a university and you require a small business to participate, because of course universities cannot participate on their own, then we can also matchmake for you there. That's by far the most common version of matchmaking that we do, but it's all free, and it's on our website. So which I'll show you on the next few slides. So next slide, please. Yeah, I wanted to highlight that we do one-on-one support for everything, and then the next one is going to be team matchmaking. So next slide. Okay, so this is where you can sign up for the process navigation if you would like. Again, it's free, and you can advertise for a partner, which just means that you want to be included in our matchmaking list. And then if you don't want to be included, but just want to see who else is included, you can search for a partner there. We do make it an anonymous list, so even if you sign up, nobody would actually know who you are. They would just know that you're a research institution seeking a small business, or a small business seeking a research institution. And you'll see that we've made this graph on the right-hand side shows that we've made a little under 350 connections. We've actually made 493 to date, and this slide is a little bit old, but next slide, please. And then on this upcoming slide, you'll see where you can sign up for the process navigation. You can apply for the cohort here. That's up and running right now for the 22.1 solicitation. The Air Force has pulled out of 21.3 to be able to actually focus more on university engagement. So if you're a university, now is a good time to get involved with the Air Force Silver Sitter. But we have a really good win rate. These numbers, again, are old. I'll tell you the new numbers. We have a 67% win rate for phase 2 and a 50% win rate for phase 1. So, you know, combined, it's around 60% win rate. And you might think, well, it's not that great. But when you compare it to other companies who do what we do, and oftentimes will charge a fee for it, their win rate is under 10%. And so ours is, you know, combined 60%. And so we're really proud of these numbers. And we are really excited to help small businesses, because if you're successful, then we're successful. And we work very hard to make sure that you're successful. And again, I know I've been talking about the Air Force, but we are capable of doing the same thing for the Navy. And as I'm thinking about it, I actually should probably break out the number of awards from Air Force and Navy, but we'll do that another day. So next slide, please. All right, this is the Parallax Learning Hub. This is the education and training slide that I was mentioning in the very beginning. We have created and launched a MOOC, a massive open online course. So think MIT open courseware that was made famous a few years ago. This is our way of letting you learn about the Silver Sitter process from the comfort of your own home or your office, and whatever time you'd like. We have found this to be useful because people can take notes, or they can go back and review the training, and you know, look for an answer that they know they heard on the course during the courses. And there are different levels. There's phase 1 certification, phase 2 certification, and then onward to phase 3. So right now, phase 1 is launched and has 24 training modules. And then phase 2 is going to be launched soon. And then phase 3 target is early 2022. So I encourage you to check this out. Again, this is free, and something that we have designed and launched to help you. I know it sounds weird when we say we're here to help you, but that really is the truth. We want to do what's best for you and make it as easy as possible for you. So next slide. I think that's my last slide. Yeah, this is the contact information. Feel free to reach out to me at any time. Of course, you can use email or LinkedIn as well. Either one works. And I would be happy to answer any questions. If you have specific business or university entrepreneur questions, feel free to email me and I will make sure that I get back to you. So thank you so much for this opportunity.
Thank you, Dr. Gilpin. Really appreciate that insight on APEX. I apologize for butchering the acronym when I first introduced you, the Academic Partnership Engagement Experiment. That's what I get for looking at it before, trying to talk to it before I looked at it. Really appreciate that insight on what the Air Force is doing and the opportunities for the Navy and the Air Force to collaborate where it makes sense and where the capabilities that we're looking into overlap. Okay, so now we're going to switch gears a little bit, start talking about specific projects in the ANTX and Coastal Trident world. So the first part of the program was focused on what the technical needs are, what the operators, what the users, what the warfare centers and our interagency partnerships are looking for as far as technical enablers, the capabilities that allow people to operate safely and effectively in domains that are challenging physically or physiologically. Port and maritime domain obviously is the one that we focus on the most. Okay, so the second part of the program is taking those needs and translating those into the things that we're doing to try to meet those needs. So ANTX-Coastal Trident is one of the programs that we run. We've been running Coastal Trident portion of it since 2007. So this is the 15th year we've conducted it. The ANTX portion of it since 2017. So it's a pretty long running sustained program. We're pretty proud of what we're able to achieve. It keeps growing in scope and reach and size. So I'm going to take that as a sign that we're providing some value for the participants and the stakeholders in the program. So I'm going to spend a little bit of time talking about what it is, how it fits within the larger scheme of what we've already heard about today, what we've been doing for the past 5 months, and where we're going from here. And I'm scheduled on the agenda to be talking for 45 minutes, but I'm probably going to be able to give some time back to our project briefings because I know they got a lot to speak about in talking about what they've been up to. Okay, so Coastal Trident, I said we've been running this program for 15 years. What is it? It's an operational research program. That's the easiest way to encompass it. So we're out in the world doing research and doing testing and learning as much as we can about how things operate, whether that's people, processes, technologies. We conduct it annually and it focuses on port and maritime security. Obviously, we're a Navy organization, so we focus on Navy capabilities as our priority. But like we've talked about, there are a lot of interagency partners in this port and maritime domain. There are a lot of authorities, people who are responsible for certain capabilities and performing certain missions. And there are a lot of other partners that have the capability that not necessarily is maintained within the Navy. So for security capabilities or incident response capabilities. So Coastal Trident strives to take this whole of society between the Navy, between our interagency partners, between the private sector, and come up with a program that explores all the capabilities to respond to threats and incidents and operational gaps that exist in this domain. And as I said, port and maritime environment, it's very physiologically and physically challenging for people to be exposed and out in this environment. There are long distances, large geographical areas, infrastructure, austerity. It's difficult to communicate. There's a ton of information. It's difficult to make sense of it. A lot of big challenges in this domain. Additionally, there are a lot of organizations that operate in these domains that their primary missions are on land. And they get put into a port and maritime environment and they don't know how to operate on ship. They don't have specialized equipment. They don't have experience with the industrial nature of a port and all the different players that come to operate in that environment. So Coastal Trident is primarily an environment where organizations can learn about the unique challenges that are in the port and maritime domain. They can bring their capabilities out into the environment to test and validate and experiment with them. And they can learn how to improve upon those capabilities so that when the time comes to implement them or put them into practice, they're ready. So here on this slide, you can see our 4 goals for the program. And these are recurring goals: reinforce relationships between all these different players that operate in these domains and establish and reinforce those partnerships. We always say the time that you want to be trading business cards is before the incident occurs, not when it occurs. We want to strengthen capabilities. Like I said, we want to take all the capabilities, both personal and technical, that exist in these domains and put them out into the field and see where they break down, see where the capabilities are mature and they need to be maintained, and then see where these capabilities really need some work and where technology might need to be applied, where training might need to be applied, really what we need to do to make sure that safe and effective operations are capable by all these different organizations. The third thing we're trying to do is explore CONEMP, which is concepts of employment, how you take technologies and use them with standard operating procedures or techniques and procedures, SOP, TTP, and then accelerate the implementation of developing technologies. So as you know, we partner with a number of different private sector and public sector organizations that are developing technologies. We've talked about a lot of the needs already today. And Coastal Trident and ANTX are designed in part to take these technologies that these stakeholders in these organizations might not know about and help accelerate the implementation and the study of how these things are going to be used and what it's going to take to get them out into the field, into the hands of the users who need them. A lot of that has to do with addressing barriers to implementation. What's it really going to take to get past the barriers that are keeping us from implementing these capabilities and these technologies? So every time we get out into the field, every time we put something into practice in training or exercises or experiments, we learn about these. And so exploring those barriers, those implementation challenges, and what it really takes to get these capabilities implemented is one of our goals. The fourth one always is figure out how we can do better next time. So we want to take stock of all the things that we're learning, identify opportunities for improvement, and really apply those opportunities and those priorities to all hazards. You know, we're not just talking about terrorism. We're not just talking about state-on-state warfare. We might be talking about earthquakes and pandemic disease and hurricanes. A lot of different threats have the capability to disrupt the safety and the effectiveness of Navy operations and the operations of all of our partners in all different environments. So we want to take these priorities and the things that we're learning and apply them to all the hazards that we might face, and see where the capabilities break down and see where the capabilities can be improved. Like I said, Coastal Trident is designed to meet the needs of a pretty wide variety of stakeholders. You've heard a lot about them today already. You'll hear a little bit more about them later. But we really do want to emphasize that this is a whole of society problem. It's not just a whole of government problem. We know that there's Navy and Coast Guard and Customs and Border Protection and all these different local law enforcement and emergency response organizations, but it's also a partnership between the public and the private sector where technology is being developed and being made available to these operational stakeholders. Okay, so that's what Coastal Trident is. And like I said, that started in 2007 as a partnership between our organization at the time, the Center for Asymmetric Warfare, and the Port of Hueneme. It's been growing in scope and changing ownership and organizations since then. I'm actually one of the few people that's been involved with the program since its inception in 2007. So a lot of history there, good or bad. But yeah, this program has grown over a long time into the form that it is today. Okay, moving on to ANTX. So in 2017, we started talking about ANTX and Coastal Trident as something that was going to be linked, something that was going to be a little bit more focused on technology. So since 2011, Coastal Trident has really started to accelerate in being an environment to not only test the operational capabilities with people and processes, but to test the equipment and the technology side of that, recognizing that with these physical and physiological limitations that we have, technology is one of the ways that we can work around that. If we have long distances, we can use communication and data links to bridge those gaps. If we have gaps in infrastructure, we can use different technologies to bridge those gaps. If we have physical limitations of seeing or hearing or breathing, technology is the way that we get around that. So the ANTX portion of Coastal Trident is how we contain and support technology experimentation and technology evaluation within Coastal Trident. And ANTX is really focused on adapting quickly to the rapidly changing threat environment. We know that we are in an environment where we're threatened, our safety and our security is threatened when we're out there operating. And we know that technology develops very quickly and that the government doesn't necessarily have the best mechanisms for harnessing that technology as a program. So ANTX is designed as part of, to describe it crudely, a tech scouting process where we have a lot of different inputs for technology that are being made available and offered up as solutions to problems that we have. And ANTX is really the field portion of that, where we take those technologies, no matter what the readiness level is, whether they're just kind of prototype level or ready for prime time, and we put them out in the field and we really put them into scenarios and figure out where they work, where they need further development, where we need to figure out better ways to use them, and where we're just kind of applying things that have existed for a while in new ways that we may not have thought of before. And again, that's the field that ANTX represents. And it's designed to be kind of a minimal investment for the Navy to learn about all these things. So companies come and they participate. The Navy doesn't have any obligation to buy them. We provide the environment for these things to come out and operate, but where it goes depends on the system and the suitability that's determined by the evaluation. And I'll get to it in a little bit, but there are a number of different ANTX programs, Coastal Trident of which is just one. So I talked a little bit about how ANTX is part of this kind of tech scouting process. You heard from Whitney and Troy about NavalX and their innovation processes. So you can see that ANTX over there in the top right corner is really the validation part of that process. There are a lot of different processes that occur before that in sourcing and developing and finding and filtering, getting to a prototype. So ideas move into products that are ready to be tested and they're ready to be discussed about in an implementation fashion. So that's really, again, where ANTX falls in that validation phase. You see there the term minimum viable product. I talked about that a little bit just a second ago. We're looking at things that might just be the first prototype that was developed from this concept. It might just be, beyond the lab. It may be the first time that somebody's turning it on. We do a lot of that in the ANTX and the Coastal Trident experimentation realm. And that's really where one of our focuses, I think, is of the greatest significance and the greatest benefit is a lot of companies, a lot of developers, they don't have the resources to get technologies out on a ship, to get them out on a range where they can turn on a jammer, to get their product on or to get their technology on an aircraft that can fly it around. So we strive to provide an environment that can support with those resources so that these technologies can really get validated and the concepts can be evaluated for their applicability to Navy or other stakeholders. And then from there, the output is really a recommendation for who needs to take a harder look at this. What development is needed to further kick this ball down the road. Or maybe the answer is it's not really a good fit at this time. We're gonna divest of it. And again, it's meant to be done with minimal investment on the part of all stakeholders. Okay, so I told you that there are a lot of different ANTXs. This slide shows kind of the history of how ANTX came to be. It was started in 2015 by the Naval Undersea Warfare Center in Newport, Rhode Island. As again, this experimental battle space where technologies can come and play and people can come see them in a scenario-based environment, and the Navy can decide, where we want to go with them or not. In 2017, a number of different organizations adopted this model and started standing up their own ANTX programs. They all look a little bit different. They're all geared toward the same space, again, kind of accelerating this knowledge about technologies and what's out there and what can be used and what we want to move forward with. They all focus on different core competencies. Every warfare center or organization is looking at something a little bit unique. And so they all look a little bit different. ANTX-Coastal Trident is probably one of the most significantly different than that, just because there's such a big focus on those interagency relationships that the fleet engages with, that the Navy ashore engages with, and where those partnerships are collaborative and where it makes sense to develop capabilities together. I said already, it has a unique focus on the whole of government capabilities, which is unique in the ANTX world, but equally as important. And so we're looking forward to getting out of the COVID environment where these ANTXs can start standing up again and accelerating the knowledge for the Navy. We expect that there's going to be a lot more engagement as that happens between ANTX-Coastal Trident and the other programs, where some of our environments may be unique, some of the other environments may be leveraged by us. So there's a lot of effort Navy-wide to harness collaboration and to streamline and align these ANTXs so that they're complementary, not as overlapping as they might be on initial glance, and to really kind of streamline and align all the processes to the best benefit of the Navy and all of our partners in the public and private sector. So you can see Coastal Trident is going to continue in 2022. We'll talk some more about that tomorrow at the in-person event, but that planning process continues. Actually begins essentially next week. So we're going to wrap this program up this week, get right into planning ANTX-Coastal Trident 22. So if you want to make sure that you're on our distribution for that, send me an email and I'll make sure you get materials, but more on that to come. Okay, so I'm talking Coastal Trident, I'm talking ANTX. How do they fit together? Are they the same? Are they different? Really, the answer is they're both. So I mentioned that in 2017, Coastal Trident, ANTX, the Port Hueneme Division ANTX program stood up. It leveraged Coastal Trident as that operational environment. So I talked about how technologies are being put out into the field. They're placed in scenarios. Coastal Trident served as that scenario environment where we had people operating in the port and maritime domains, conducting missions, and we had the opportunity to put technologies in their hands and to see how they would have changed or enabled or improved their SOPs, their TTPs, their capabilities to accomplish their missions in all of these different challenging scenarios. So Coastal Trident served as the venue for that experimentation. And it really, again, was a unique opportunity for people to take a look at technology, for technologies to get some awareness and some insight into what the operational challenges were, and for the people who are developing technologies to get access to the people who are going to be using them. And really the goal here is focus all the different capabilities and the subject matter expertise that's out there, again, in that whole of society. We're talking about government at the DoD, non-DoD, federal, state, local government, special districts like ports, and international governments as well. Industry, academia, so government labs, academic labs who are developing cutting edge technologies, either independently or in partnership with government labs. The focus of the ANTX is to kind of narrow those capabilities and that subject matter expertise into a focus on Navy priorities and technical needs. Now, again, at a base level, that's what ANTX is about, but we know in practice, especially in Coastal Trident, that a lot of those interagency partners and those partners from other services where the capabilities overlap with the Navy are going to be working with us. So on the surface, in the name, it's Navy focused, but in reality, it really does stretch across that whole of government and that whole of society, because there are a whole bunch of different stakeholders that need those capabilities. So when we talk about Coastal Trident 21 and ANTX-Coastal Trident, really, again, we're using Coastal Trident and the history over the last 15 years that we've developed as an operational test ground to serve as the scenario-based environment in which we can put technologies that are relevant to the Navy and our interagency partners. And you can see on this slide, it shows kind of the 4 focus areas that really apply to ANTX in leveraging Coastal Trident. So in-service engineering, maintenance, and supportability capabilities. These are not the traditional warfighting capabilities as you would think about them, but critical to sustaining the way that the Navy operates. So how do you remotely support a ship if it's damaged or attacked in the field? How do you repair it? How do you provide support to a sailor on a ship if he's not able to come into port and get support in person? How do you address some of these long-term maintenance and supportability issues for ships that are aging or ships that are going into the fleet and not necessarily fully understood? Moving on, sensor data fusion, maritime communications, decision support tools. I talked a lot about the maritime environment. We talked a little, excuse me, about the maritime environment as this wealth of information that we need to harness. There is all the information in the world out in the world, and we can't do anything with it unless we can filter it and organize it and prioritize it so that a human brain can understand it. So sensors, data fusion tools, communications and data links, and then some of these tools that can help us prioritize that information and filter it and organize and visualize, that allow us to make sense out of it and provide it to somebody, the right person at the right time, to make the right decisions that will allow us to operate in these environments. Some of the capabilities that are enabling that on the next bullet: multispectral imaging and sensing, virtual augmented reality interfaces, and digital engineering. So those are tools that will help us visualize these environments that are complex. There are multiple domains. Talking about multiple domains, we're talking about air, surface, and subsurface, all of which are critical to operations. We have vehicles and people operating in all those domains, and we have very little ability with our own eyeballs to transition between these domains when we really need to know about everything that's happening there. So all the sensors, all the data fusion tools, all the visualization tools, and those interfaces that can help us understand those are one of the areas we're focusing in. And then you hear a lot about unmanned systems, aircraft, surface vessels, ground vehicles, underwater vehicles, the applications for those in dealing with the limitation of us as humans to, can't fly. We can't traverse great distances on the surface of the water. We can't last for very long without technological support under the water. So unmanned systems are some of the ways that we're dealing with these challenges to reach out in the air, to operate on long distances, and with persistence or covert capabilities on the surface to traverse long distances, or again, operate with persistence or stealth under the water. Unmanned systems are the name of the game there. But we also want to make sure that our enemies or our adversaries, those that would do us harm, don't have the ability to leverage those same unmanned systems against us. So countermeasures are a big thing, a big focus area for us in the ANTX and Coastal Trident programs, not only just for, counter drone systems, unmanned aircraft that you hear the most about, but how do you stop an unmanned surface vessel? How do you defeat an unattended sensor? How do you defeat an unmanned underwater vehicle that is very hard to detect is going to be there for a long time and has some capabilities to inflict very significant damage on critical infrastructure. How do you defeat those, and how do you work around the barriers that organizations encounter when they want to employ those? One of the things that we found is that, especially in countering unmanned aircraft, there are a tremendous amount of really good capabilities out there for jamming drones, for knocking them out of the sky with kinetic projectiles. I'm sure you've heard a lot about all those different capabilities, seen some pictures of them, but the reality is there are significant challenges to administratively, logistically, politically employing those systems if we're not in a wartime situation. So you get a local law enforcement organization that wants to jam a drone. They don't have the authority to operate that because the FCC doesn't allow them to transmit interference, and the policy around jamming the aircraft is that it's essentially hijacking that aircraft. So there are policy changes and administrative procedures and, you know, really a lot of barriers to implementing those capabilities that we find out about in the process of experimenting with and really want to work around as one of those steps forward. So that's how ANTX fits into Coastal Trident. Again, kind of to summarize that, Coastal Trident is the umbrella opportunity for people and technologies to come get out into a scenario, operate in the environment. ANTX is a subset of that that focuses on Navy capabilities. So hopefully that's as clear as mud. It's confusing for me sometimes to realize whether we're talking about ANTX or Coastal Trident, but the reality is that they go hand in hand and they're very complementary. Okay, so this is what Coastal Trident, ANTX-Coastal Trident 2021, I just did it right there. ANTX-Coastal Trident 2021 looks like this year. This is the administrative design of the program. So this chart right here represents 55 different projects. You can see all the different subject matter areas that it addresses. There aren't 55 numbers right there, but a lot of these different projects, especially in the unmanned systems applications, have 3 or 4 or 5 sub projects. So that's where we get to the 55. So this is organized into all of our different focus areas that we look into as part of this program. Port and Maritime Incident Response Module 1, that's typically our exercise activities where we're looking at our operational stakeholders and getting them out into an environment to train and to conduct exercises. And that module usually represents our opportunities for environments and venues where we can get technology into the hands of users and really get some benefit of the operational insight. Module 2, kind of a hybrid between exercises and experiments when we're getting into talking about port security and critical infrastructure protection. The port of Hueneme, as part of Coastal Trident, one of the focuses has always been on accomplishing their annual requirements to conduct a security exercise. So you can see that module 2.1 is their port security exercise. So that's something that in our 15 years of executing this program, we've always maintained as a priority, is to help the port satisfy that requirement that is upon them every year. Then we start getting into all the different technology demonstrations and technology experiments. And I do differentiate between those two, demonstrations and experiments, for a deliberate reason. So some of the technologies, like I said, are a pretty low readiness level. They are just coming out of the lab. There may only be one prototype. It may never have been switched on in the environment. And the objectives of that participant is really, look, we want to put it in the water and make sure it floats. And that's an experiment. They want something, they want an environment in which they can learn about that technology and see whether it's suitable for the environment, learn where it breaks down, learn where, you know, they've developed a brochure for it, learn where the capabilities don't match up with what they're promising in the brochure. And so that is, you know, our experimentation focus. And sometimes technologies are a little bit further along. They've been doing scenarios and they're ready really to transition from this kind of compartmentalized experimentation environment and really graduate into more integrated exercise where standard operating procedures and tactics have been developed for this system, and they're really ready to integrate them into the fleet or into the hands of operational users. And that's another element of experimentation. Some of the participants really just want to get eyes on their technologies and get some feedback on whether it's useful or whether it's going to be effective, whether it's going to be suitable. And the objective is really more of a demonstration than an experiment. So they want to come out and put it in an environment where people can watch it and people can see it and people can learn about it And really, we have the opportunity there to connect them with the people who need it. And so the purpose is really more of a demonstration, and they're really more looking to learn about the connections and the relationships and the engagement opportunities than the capabilities of the technology themselves. So those are all sprinkled between modules 2, 3, 4, 5, 6, and 7, where we have different focus areas. And these focus areas, you know, they kind of maintain some similarity year to year. They're kind of organized into things that we're always really looking into, with some minor changes, but it's pretty consistent for the past few years that these are the modules that we organize all the projects into. If you've been involved in ANTX-Coastal Trident before, you know that these numbers have absolutely no meaning when we actually go out into the field. This is the administrative organization of the program. It helps us tell the story of what we're doing. But when we go out in the field, we really use these modules as plug and play opportunities. So we will take a module from here, a module from there, where the resources are common or the stakeholders are common, or it's just a good opportunity to put two things together that make sense. And so we might plug module 5.1 in with module 3.3 Delta and put that into exercise module 1.1. So it gets a lot more complicated when we're planning and executing. But again, this is just kind of how we administratively organize it and tell the story. You'll see project briefs from some of the projects that we've executed this year after I'm done talking about what we're up to and what we've planned. And then you'll see a little bit more how the modules interact and how they work operationally. Okay, so this is what we planned and what we set out to do. COVID-19 in the real world and all of the challenges that we've all been facing with getting technology ready, getting things shipped, getting things developed and produced, traveling, gathering in large groups. This is what the program looks like today. The green lines are projects that we've completed. They were successfully completed as planned, or some of the projects we had to scope down a little bit or change the scope, but those are projects that we've successfully completed. The red lines are where projects have had to be withdrawn or postponed until next year. And most of those ones that are red have requested to postpone until next year. And some of those were just challenges in people traveling, challenges in people getting together and planning operations or experiments. Some of them were, they just couldn't get the technology developed and ready in time. Some of them were, hey, rather than focusing on experimentation and demonstration, we've focused on getting contracts, and we've successfully got contracts with the users, and we really don't have a need for this environment anymore. So there's a good mix of those reasons as to why these projects were withdrawn. But 22 of 55 projects were withdrawn this year. Kind of the complicating factor there, or the challenge, is that we still had to plan all these activities as if they were occurring. And the reality is that in planning all of these engagements and all of these participations in scenario-based activities, we learned a tremendous amount about how these systems and these technologies are going to work, what some of the issues are. We've had people in our group say that 75% or more of the learning is gained in planning. Execution is just kind of a formality. And that really is true in this case. We learned a tremendous amount about these capabilities and where we want to go with them, even if we didn't get to execution. So even though those are red and those projects were withdrawn, they still get written up with some significant lessons learned that will be able to be shared and be able to be capitalized upon by people that are operating in these domains and along with these partnerships. So good news story there. So even though we may not have gotten to execution there, there's still a lot of return on the investment in planning and the relationships that were established. The black lines are still pending completion. Those are all projects that are going to demonstrate or experiment this week or next week. September 29th will be our last event next Wednesday. And then October 1st, we're off to the races for 2022. So that's what the program looks like again this year. Again, it's a little bit misleading with the red. Red's typically associated with bad. Those just aren't our projects that we didn't quite get to execution. But like I said, tremendous amount learned, significant knowledge gained in most of those projects. Okay, I just want to share a couple pictures. Talked about some of the different environments that we're able to have access to through the ANTX-Coastal Trident program. So you'll see some of those environments here. We've got offshore oil platforms. We've got land-based test sites. We've got offshore test sites with a variety of different types of vessels. One of the things that we like to do in the ANTX-Coastal Trident program is make use of non-traditional resources. So, you know, like I said, a lot of the technologies that we have as participants, they don't necessarily need a fleet vessel that we're going to take out of operations that they're conducting or training that they're conducting. We don't need to take that fleet vessel out of the fleet to be able to conduct these experiments. We can conduct them at sea on research vessels or commercial vessels or offshore support vessels. And we have a pretty wide network of resources that we're used to taking care of. The benefit of that is it ends up being a lot more flexible in time. We end up being able to get a lot more projects involved, and it ends up being cheaper, frankly, to the Navy than if we were to really chase after these, you know, these gray hulls. So we have a lot of flexibility, and again, kind of demonstrate some ingenuity in reaching out and grabbing these resources that will get people out on the water if they don't necessarily need to be integrated into a, you know, a technically Navy or aircraft or vessel. That said, we do have a lot of opportunities to get aboard Navy vessels. So if that's something that you really do need, you know, don't think that we can't get those resources for you. But again, like I said, vessels, offshore oil platforms, land-based test sites, offshore test sites at sea, and a lot of different tactics that we've used in the past to work around some of the challenges in getting these projects done effectively and efficiently. We do like to take advantage of some of these non-traditional test sites where maybe it would be, you know, the most common practice to go out on a Navy test range and get that dedicated range time, but that's expensive and it costs a lot of time in personnel resources to get that all planned and approved, when we might be able to go reserve a city managed test site that's over the land and learn the exact same kinds of things. To maximize the benefit and minimize the resources available. And our ability to do that and the necessity that we have to be good stewards of the resources that we have and to accomplish the maximum amount of benefit with the minimum amount of resources, that is really why we are so distributed in time and place. You look at some of the ANTX programs that are conducted around the country, and they are very good at consolidating people in time and place and getting a lot of people in one place to get a lot of eyes on projects. We're a little bit different like that. That's not something that we're so good at, and we are dispersed in place and in time. And that's one of the reasons why we conduct this open house, is because we are so dispersed out on ships, out on oil platforms, you know, spread across 200 miles of coastline over a period of 6 months, that we don't get a chance to get all these people together to collaborate and talk about what they've done, to share the knowledge outside of an after action report. So that's really why we started conducting this open house, as an opportunity to bring back everybody into one place, talk about what we did. Like we said before, the content has already been done. This is about the contact. And allowing for the engagement that really is part of the significant benefit of these programs. It's about learning out in the field and doing that part too, but it's about planning the further engagements that are going to carry these projects forward and really result in them being implemented and applied in the operational environment. So again, these pictures are just kind of examples of where we've been this year and what we've been up to. And more to come. That we've been taking pictures everywhere we go, and we like to put them in the after action reports because they really do tell the story of what kind of technologies we're looking at, what kind of environments we're operating in, what kind of organizations we're working with, and how impressive the spread of influences through Navy, non-DoD, federal, state and local governments, and the private sector partners who are developing these technologies. Okay, so that's my last slide on explaining ANTX and Coastal Trident, how it all fits together, what we've been up to this year. I've bought us back a little bit of time in the agenda, so we're gonna move on and start into our project briefings. So the idea on these project briefings is, unfortunately, we couldn't offer all the projects an opportunity to brief, but we did take a sampling of representative projects that are good at telling the story of, you know, kind of the flow of the discussion here. So in the beginning, we talked about what's the operational need. I just talked about ANTX-Coastal Trident as an opportunity or a venue for technologies to come in and be evaluated as meeting those needs. And so the projects now that we're going to talk about are really good case studies and really good at telling the story of how technology developers are able to come in, take a look at a specific operational need, identify a technology that's either being developed or used in another application, and apply that in an operational environment to be offered up as a solution. So again, those are the project briefings that we've selected, and I think it'll be very interesting for you to be walked through the process of how that worked and to see how these different organizations were able to engage and get their needs met, but also move us towards meeting the needs of the users and the operational stakeholders. So again, as before, these presentations are going to be a mix of people in the virtual environment. Some of them are joining from their hotel room. Some of them are joining from their office. I believe Elliot Donald from Saab is online. I believe he's in an airport lounge. So glad that we've got this interface for him to come join us. Mr. Donald, if you are with us, carry us away.
Sure, thank you. Yes, I am speaking to you from Providence TF Green International Airport. Yeah, I'm going to talk about the Persistent Change Monitoring and Intrusion Detection System, which is a system of systems that we've put together between a number of different technologies from to provide persistent subsea residence without any support from a platform on the surface of the ocean. So without further ado, I think we can roll right into the slides. All right, there we are. As I said, I'm Elliot Donald from Saab, and this morning I'll be speaking about the subsea residence that our team, comprised of Saab, Columbia Power, Hibbert Inshore, ASL Environmental Sciences, R2 Sonic, and Biosonics will demonstrate at the Wave Energy Test Site, or WETS, off Marine Corps Base Hawaii over a 6-month experimentation period. Slide. Saab has been a player in the underwater vehicle industry for over 30 years. Our robotic systems are employed in demanding tasks spanning a broad scope of underwater operations. These include observation, inspection, survey, ordnance clearance, marine science, and environmental monitoring, to name just a few. During Coastal Trident 21, a Saab Sabertooth with installed sensors from R2 Sonic, Voyus, and ASL Environmental Sciences will perform some of these operations. Slide. Saab's initial efforts in underwater vehicles involved the use of tethered vehicles supported from vessels on the surface. In removing the hazard associated with manned operations at depth, this led to greater time on station available to perform undersea tasks, but also brought with it the costs and carbon footprint associated with the support vessel on the surface. Slide. Recently, the concept of subsea residence has advanced. Under this concept, ROVs take up residence in garages located on the seafloor. Subsea residence increases ROV availability and extends on-station time while reducing costs associated with support infrastructure. In this image, you see various resident vehicles conducting both tethered operations in the foreground and a Saab Sabertooth conducting tetherless ROV operations with a free space optic blue dome in the background, with power and communications provided through the platform. Slide. The challenge we have now is to remove the infrastructure, whether installed or afloat, to allow us to realize truly unmanned operations while sustaining persistent presence in the undersea domain. Slide. In our Coastal Trident project, we address that challenge with a demonstration of persistent presence with the Persistent Change Monitoring and Intrusion Detection System, or PCMIDS, a system of systems which will perform infrastructure security surveys, area surveys, and environmental monitoring tasks with no requirement for sea-based fixed or mobile support, either to provide power to the vehicle or communications between the vehicle and shore-based controllers. So, with our introduction complete, I'll walk through the remainder of the agenda, which includes an overview of our project at the Wave Energy Test Site in Hawaii and what we hope to achieve, Some details associated with the different technologies that comprise the PC mid system, and an outline of the planned operations, both at what will amount to a rehearsal for Hawaii operations in Lake Michigan and the Coastal Trident event itself in Hawaii to be completed early next year. Slide. In execution at the Wave Energy Test Site, PC MIDS will demonstrate true subsea resonance. The Sea-Power Sea-Ray Autonomous Offshore Power System, or AOPS, acts as a charging station, data server, and cell tower while providing reliable in-situ power, energy storage, and bidirectional data transfer between subsea resident systems and remote operators ashore while enabling net zero carbon emissions. Slide. A Hibberd inshore designed AUV docking station will serve as the interface between the Sea Ray and the Saab Sabertooth hybrid underwater vehicle to support both power and bidirectional data transfer. Over a 2-week period, this arrangement will enable Sabertooth's residence at depth while it collects imagery from the R2 Sonic 2024 multi-beam echo sounder and the Voyas Insight Pro laser scanner during infrastructure and seafloor surveys. Meanwhile, the ASL Environmental Sciences Acoustic Zooplankton Fish Profiler will collect sea life information simultaneously but not interfering with those survey operations. The collected data from these tasks will be uploaded to the cloud while this vehicle is in dock, all without any manned support to the vehicle from the ocean surface. Next slide. Throughout the project, the Biosonics Marine Life Observer, or MLO, will monitor the area in the vicinity of the AAV docking station for marine life and pass that data to shore continuously via the Sea Ray. Slide. Columbia Power's Sea Ray provides wave-generated power from a buoy on or near the surface, energy storage at a base station on the seafloor, and between the two of these, real-time bidirectional data transfer between subsea resident systems and the cloud, allowing communications between unmanned mobile and static undersea assets and minimally manned command and control centers ashore. Agnostic to the geographic location of the payload, the AOPS is designed to survive 100-year storm conditions of the U.S. Pacific Northwest and is available in drifting or moored configurations. The 2 kilowatt capacity AOPS that will be used at the Coastal Trident will have 33 kilowatt hours of energy storage, fits in a 40-foot standard shipping container, and can be deployed with a lightly crewed vessel. Once the system is deployed, no support vessel will be needed. Sea Ray enables truly unmanned and persistent presence for both autonomous and connected systems, as we'll show in our experiment. Slide. Hibberd Inshore is an experienced ROV and AUV services provider that has been providing robotic vehicle services to both government and private industry clients since 1984. Hibberd was the first commercial operator of the Saab Sabertooth vehicles, which they have owned and operated since 2011. For this project, Hibberd Inshore will provide the following services: planning and programming of the Sabertooth AUV for task execution, design and fabrication of the vehicle docking station, design, fabrication, and supply of the interface for vehicle charging and data transmission between the Sea Ray base station and the Sabertooth AUV, and many other services. The Hibberd docking station is designed to allow real-time monitoring of the vehicle docking process through the Sonodyne Bluecom optical data transmission system and cameras and associated cameras on the vehicle itself. The onboard charging interface and data transfer system will allow for bidirectional transfer of power and data between the Sea Ray and the Sabertooth AUV. Slide. The Saab Sabertooth is a hybrid AUV ROV and capable of working in deep water and can operate as an autonomous vehicle running pre-programmed mission plans or as an ROV via either a physical fiber tether or using optical data transmissions such as Bluecom as a tetherless ROV. Its power, stability in dynamic undersea environments, adaptable tooling, and ability to maneuver precisely with 6 degrees of freedom make the Sabertooth well suited to providing persistent presence undersea. For Coastal Trident, Sabertooth's adaptable sensor interface will enable the integration of the R2 Sonic 2024, the Voyus Insight Pro laser scanner, and the ASL Environmental Sciences AZFP. Planned to remain submerged for a 2-week period while operating from Hibbard's subsea docking station, the vehicle will be tasked in various sensor and altitude configurations to inspect underwater infrastructure, perform underwater survey operations, and conduct environmental monitoring. Slide. The ASL Environmental Sciences Acoustic Zooplankton Fish Profiler is a compact, low-powered, calibrated multi-frequency sonar for environmental awareness and has had numerous applications in its employment history. These applications expand beyond measuring sea life and include measuring the following: ice cover, prey fields for whales, air bubbles near the surface or gas bubble plumes, subsurface oil plumes, and suspended sediments at 1200 and 2000 kilohertz frequencies. ASL has worked with the Naval Research Lab on plankton counts, oil plume measurements, and Arctic bubbles. Thus far, the more typical use of the AZFP has been as part of oceanographic moorings and much smaller underwater gliders. While there are roughly 220 instruments in use, this will be the first employment of the AZFP on the Sabertooth-like vehicle, where in an upward-looking orientation, the sensor will measure marine life coincident but without impact to the Sabertooth's tasking to collect imagery with its other sensors. Slide. The Sonic 2024 is the highest resolution multi-beam echo sounder available, with a 3mm bottom detect range resolution and a 0.3 by 0.6 degree beam width at 700 kilohertz, combined with 1024 soundings per ping and up to 60 hertz ping rate. Superior object and change detection are two of its many strengths. Its exclusive one-pass multi-frequency capability allows for the identification of areas conducive to mine burial and superior characterization of superficial sediments using all of its available frequencies from 170 to 400 kilohertz and 700 kilohertz. With an available pressure rating of 6,000 meters, R2 Sonic sonars are proudly made and sourced in the USA, with over 1,700 systems sold worldwide since 2009. At Coastal Trident, the 2024 will serve as the primary search sensor to conduct inspections of underwater infrastructure and area surveys of portions of the sea floor at 400 kilohertz and 700 kilohertz. Slide. Voyus, a Sonodyne Group company, specializes in underwater three-dimensional laser scanners and high-definition stills cameras. This technology is being used by navies in mine countermeasures missions from autonomous vehicles. In these missions, the laser scanner captures up to 90 laser lines a second, while also synchronously capturing high-definition stills images as a subsea vehicle traverses the MCM area. At Coastal Trident, the Voyus Insight Pro will be employed for object identification following 2024 search tasks. Given a list of contacts of interest, Sabertooth will perform reacquire tasks, which enable the Insight Pro to collect high-resolution imagery suitable for contact identification. Slide. The final member of the team is Biosonics, which brings the Marine Life Observer, or MLO, to Coastal Trident 21. The MLO is a multi-use active sonar, target observation and reporting system, with two integrated components co-located in one stationary seabed-mounted platform. These are an omnidirectional target detection sonar, capable of detecting large marine life and other targets out to several hundred meters in any direction, and a directed classification sonar to track and classify targets of interest. For Coastal Trident, we'll place MLO system on the seabed at a location within 100 meters of Sea Ray Base Station and the AUV docking station. System-generated alerts and alarms will be passed to operators via the Sea Ray. The MLO will focus on Sabertooth docking station and provide indication of contacts that could represent a potential threat to the station. and monitor the docking station for marine life that saber-tooth maneuver might endanger. Slide. I'll now describe ongoing efforts leading up to the employment in Oahu. Components of PC MIDS will demonstrate subsea residence in the Great Lakes as a rehearsal with the full system of systems in operation as planned at our Coastal Trident effort at the Wave Energy Test Site off Marine Corps Base, Hawaii. Slide. Prior to the demonstration in Hawaii, Hibbert Inshore will use the Saab Sabertooth for a NOAA-sponsored project, development of an under-ice ecosystem observations capability using autonomous underwater vehicle technology in Lake Michigan. This effort will verify procedures and equipment setup for acoustic position of the ROV for navigation from the Muskegon Channel to desired areas of study in Lake Michigan for invasive species study, with an ultimate goal of mimicking the conduct of under-ice operations without having the AUV surface at any time during the operating period, and serve as a precursor to actual under-ice operations scheduled in 2022. Slide. The Lake Michigan project serves as a dress rehearsal for Coastal Trident, as all the sensors and systems associated with the Sabertooth operation in Hawaii will be employed there. These will include the Hibbert Inshore Docking Station, the Sabertooth vehicle, the R2 Sonic 2024, the Voyas Insight Pro, and the ASL AZFP. The primary difference in Lake Michigan project is that the docking station will be interfaced with power and communications provided from shore via cable instead of from the Sea Ray. Slide. At the wet site, power and data transfer to and from the subsea resident systems will occur without physical connection to a shore-based infrastructure. The Sea Ray will serve as both the energy supplier and as the pipe for bidirectional communications between the shore and PC mid subsystems. The Sea Ray will transform wave energy to power the Marine Life Observer through the docking station, the Sabertooth, with its installed sensors. It will also provide a conduit for bidirectional communications between shore-based operators and the MLO and docking station, where the interface with the Sabertooth will occur for both upload and download of mission data and for the direction of tetherless ROV operations using the Sonodyne Bluecom optical transmission system. Next slide. As an overview of Coastal Trident, Hibbert Inshore will direct employment of the Saab Sabertooth from a shore-based location represented at starred position 1. Upon successful setup and testing at the demonstration site at position 2, the Hibbert team will return to their control station and perform daily monitoring of vehicle operations. They will ensure both the download and execution of mission programs and the success of vehicle docking evolutions at the docking station. The Hibbert team will perform initial pre-processing and decimation of data subsea, and through the Sea Ray onboard communications will transfer that data to shore as necessary. The Saab Sabertooth, equipped with the R2 Sonic 2024 and the Voyas Insight Pro and the AZFP, is planned to remain resident on the seafloor at Kaneohe Bay for 2 weeks while operating from the Hibbert docking station and sustained by the Sea Ray AOPS, with the MLO at position 3 standing overwatch over the docking station and the Sea Ray base station. Slide. During infrastructure survey, the Sabertooth will conduct iterative surveys of the underwater cables and moorings that are installed in the Wave Energy Test Site. While perhaps not as elaborate as the infrastructure of a working harbor, this surrogate for harbor infrastructure will serve to and the survey of that infrastructure will serve to demonstrate the improved awareness of threats or damage to underwater infrastructure that subsea residents can provide. Through the course of our first event, Sabertooth and its installed sensors will be configured remotely via Sea Ray to enable different tasking profiles varying sensor employed, sonar frequency, and vehicle altitude to provide different data sets, each having variations in resolutions and speed of mission accomplishment. Slide. During the second event of our project, the Sabertooth will initially employ the R2 Sonic 2024 at 400 kilohertz to conduct a sonar search of an area on the seafloor. Subsequently, the Sabertooth will return to identify objects of interest in that area with the Voyas Insight Pro. This series of tasks simulates the search, classify, and identify phases of the mine countermeasures detect to engage sequence. In follow-on tasks, Sabertooth will conduct additional sonar searches of the same area on the change detect surveys, demonstrating the improved awareness of underwater threats to shipping that persistent presence enables. In later missions, shore-based operators will vary the configuration of the Sabertooth sensors and flight plans, and the search area will be adjusted accordingly. The broader search width of the 2024 at 400 kilohertz as a function of vehicle altitude will enable the search of a larger area for a given task period, or multiple passes over the same area depending on mission requirements. The narrower search width of the 2024 at 700 kilohertz or of the Voyas Insight Pro, if employed as a search asset, will require reduction in search area for the same task period. Slide. The C-Ray removes the need for sustained sea-based support to subsea resident vehicles. There remains a challenge of getting the vehicle to and from the area of interest and of periodic maintenance to the vehicle. In the third event of our project, we will demonstrate the ability of the Sabertooth to return to shore and deploy again to its subsea station. Such capability enables vehicle maintenance and other support, data transfer for larger files, and a change out of sensors or tooling as mission requirements change. It also demonstrates capacity for improved covertness, as except for vehicle recovery and deployment at a place distant from the area of operation, the entire mission remains subsea. Slide. That concludes our event. In summary, our experiment is ongoing with completion to occur early next year. The C-Ray Ops acts as a charging station, data server, and cell tower while providing reliable in-situ power, energy storage, and bidirectional data transfer between subsea resident systems and remote operators ashore while enabling net zero carbon emissions, enabling truly unmanned operations. The Sabertooth, with its maneuverability and stability, is well suited to sustained undersea operations, and with its adaptable interface, bring a mix of sensors and tooling to subsea residents. And the right mix of sensors attached brings improved maritime domain awareness to the undersea. Slide. These are the points of contact for our project. We'll be happy to answer any questions at our booth tomorrow, or if there's, thank you.
All right. Thanks, Elliot. Really appreciate you sticking to your time and squeezing all that information in there. That was great. So this is an example of a project with obviously a bunch of different applications, kind of unique for a Coastal Trident project in that it's actually been going on. It's going to span 2 years of the project, but just wanted to, make sure that Elliot and Saab team got able to give you an impression of the ways in which unmanned systems are meeting some of the needs and in which they're engaging with some of the different stakeholders and organizations to get those needs met. Sorry. So thank you again, Elliot and Saab. Okay, our next presentation is from the Naval Surface Warfare Center at Carderock Division, Module 2.3, which is called Digital Threat Protection for Additive Manufacturing Applications. Mr. Scott Ziv is going to give you a brief on that. Sir.
All right. So I'm Scott Ziv from the Naval Surface Warfare Center, Carderock. I guess I'll start off by thanking the FathomWorks guys for getting this set up. It's a really nice venue to go through and demonstrate this technology. This one's a bit of a different take on kind of the digital side of stuff and kind of combining that with additive manufacturing. They're both kind of big buzzwords. We figured we'd try and untangle kind of the vagueness of it and see if we can actually build an operational demonstration of a good use case for a digital tool. So next slide. So for starters, I guess, whenever you hear blockchain, you typically think Bitcoin. Like that is the most common application that people think of whenever you think it instantly combine the two. In truth, blockchain is actually used for a lot of things beyond digital currencies. It's being used in hospitals for medical records, being used in other stuff like that. interesting thing that blockchain provides is whenever we think of data, we think of it kind of like property. Like you have a computer, and on that computer is a hard drive, and that hard drive is owned by you, and therefore you own the data. Whereas blockchain is a little bit different because it's a distributed ledger. There's all of that data is distributed amongst a bunch of computers, and every computer has all of the data. So where is the data? It's everywhere. Everyone has it. It's just only one person with the right keys can move it or change it. So what we've built is a minimum viable product that kind of uses that technology and that tool to kind of advance the development of additive manufacturing and get it more closer to deployment. Like, how can we use that tool to develop that? So we built a minimum viable product that demonstrates that value of that technology for digital thread integrity. And I will use the word integrity very specifically because integrity and security are very different things. When you think security, security is how do I make sure my adversary can't see what I put on this chain, right? And we actually haven't protected that on purpose just so that we can kind of show how it works with more transparency. You can obviously encrypt stuff and then put it on a blockchain, but we're really kind of concerned about integrity for this. Integrity is basically the how do I know that the part that is sent is the part that is received? And how do you make sure that it's not tampered in transit, right? Whether that's from an adversary or just an insider threat, or just generally not being aware of, a sticky zero key that adds an extra zero on something that you're supposed to have. The making sure that what you send and what you approve is actually what you get in the end. So we've kind of developed that side of building out a blockchain and then having that tool and that data being used by a very specialized additive manufacturing system. I'll talk about that in a bit, called a fabricator. If you play video games, it's actually based off of the fabricator from Gears of War 4 of the same name. But it actually is this very interesting little Pelican case that has a printer inside and uses blockchain to pull down these verified approved part files and settings and all the systems needed to run the part, and prints that in an environment that may or may not be well known. So we basically use this blockchain side and all the value that blockchain adds to protect these part files in an unknown environment or an unknown zero trust environment that may or may not be the same conditions that you'd find, in a lab. Next slide. Oop, get me back a couple. One more. One more slide back. Oh, I guess next slide. Okay, that works. So this is a little dense of a slide. I guess I'll just start with kind of the top right there of what kind of like just basic overview of the network as itself. So blockchain networks, they are a little bit different from standard server networks because again, it's not on a server somewhere, it's everywhere. It's every computer has the entire system, which introduces some interesting challenges and interesting threats that you normally wouldn't find, but it does have additional benefits. When you're talking about things like AUV flight paths, we just talked about jamming AUVs, right? If the AUV had all of the networks for its flight plan on board, you wouldn't need to jam it, right? Because you're not controlling it. That offers another thing, but it also has its own challenges. So this network doesn't have a central server. It just needs enough touch points between different nodes. We've divided our systems up into 3 separate nodes. The first 2, the submitter and the approver, work to build out a blockchain. Their whole goal is you submit data and then it's approved and then you build out a new block in that chain. So the first node we have here is a submitter that can take, anybody can be a submitter. They can send up a part, send up a transaction or a new revision to this file. What we've done is instead of taking financial transactions like they have in Bitcoin, we take a bunch of data and we shove it all into a zip file and we send that up instead. So instead of saying, hey, I'm going to send you $5, I say, hey, I'm going to send you this data package essentially. We zip that up as a proposed transaction that goes up in something called the memory pool in the blockchain. And then the approver pulls down memory pool transactions and says, I'd like to reject this, at which point then it dies, or I'd like to approve this, at which point the approver mines it into a new block, which is basically adding a digital signature on the end of the block. This adds more integrity to the system because in order to, you can easily check if the file that you sent is, or the file that you got is the one that was sent by just checking the hashes inside the blockchain. Not going to get too involved in that technical side, but basically it helps you secure the whole system, and having to go back and rewrite the system afterward. If you like, let's say you wanted to change something in revision 2 or after it's been approved, you'd have to go back and do the entire chain again, essentially. And that's just not that easy. So this helps you build out a chain, and we've got some interesting tools for approvers to take a look at these digital files and review them quickly. So the differential checkers for geometrics. So let's say you have 2-part files. What changed? Do you know it changed, right? Like, what if somebody put a void in it? What if there's a crack? What if somebody just, changed the size of a hole? If you just look at that, it's not kind of hard to tell. So we made a nice geometric diff checker that you pull the 2 parts in, it overlaps them, and you can say, hey, this is what's different. And of course, we have our setting diff checker there. For additive manufacturing, it's nice because it doesn't require too much human interaction, but that also means that easier to use also means easier to mess up sometimes. And in the setting world, one setting can ruin a print. And there's, I think the slicer that we're using, has close to 1,000 settings you can change. So only one can mess it up. So we also have a nice diff checker for what was your last approved version, and then what does this new proposal have? And then you can easily check those and say, okay, here's the new geometric changes, here's the new setting changes. I, as the approver, know what I'm looking at here. I like this, and then submit it off. So, or like it and then sign it and then mine that into a new block. So next slide. So what do you do with that data? So this is kind of the next side of this is once we've got a chain of approved parts, then you can actually try and use that tool to make it easier for the warfighter in the end. So I've talked to a couple of sailors and Marines, and a lot of them, while they really like printers and they really like using printers, and printers add a lot of value, they really don't need to be scientists. When you get a technical data package, it typically has, what settings you have to use it on, you have to copy all these settings into the machine. And that's a little challenging. Whereas if we have all that data already, verified on a blockchain, we can kind of just build essentially a bot that goes onto the chain, pulls the data down, and just kind of automates that whole process. So we built what is essentially a vending machine in a box. It's basically just a Pelican case with a big touch screen. It says, here's my 3, demo parts. Check and see if there's a new version on the blockchain from another node. And if it finds one, then it just updates on the vending machine. You say, I want this, go. And that's all you have to do. All the settings, all the slicing, all of the really kind of technical work is already saved in the blockchain, and you don't actually have to know it, which helps a lot in deployment, because then it reduces the training requirements to very, very little. It's not 0, but it's very little. So you can just hand this to somebody in the field and they can just go. We've also found, we added this thing down here called environmental compensator, just because it's an interesting thing that we haven't really seen that much of yet. Whenever you think of, qualifying AM components, you think of like, okay, here's this device. If you look at the manual, it's got an operating temperature and operating humidity, that sort of thing. That's the operational conditions that the OEM has said, you'll get consistent parts if you run in these conditions. That's great, except for printers being pushed into more and more demanding operational environments. A ship that rocks around a lot is not very helpful. Whereas, I've also seen Marines that take printers up, to the snowy mountains here in California. And those are way beyond the operating environments of what you'd expect your appliance to work on, right? And there's been a lot of work going into like the developing a go, no-go gauge, right? So you can say, okay, if I am in this condition and I'm in this environment and, all these things are met, then I know this is a good part, which is great, except for the fact that if you're in a big demanding environment, then all you're going to get is just a bunch of like no-goes the whole time, which, while interesting, that kind of has the I'm not a security guard, I'm a security monitor problem, where it's cool and nice to know, but not actually that helpful. So we're trying to see if we can use that knowledge of what we have to adapt the printer's behavior in real time based off of the environment, and then use that to expand that window of operation, right? A perfect example we've got here is acceleration. So if you're throwing things around on a ship, then your motion is going to be a little bit wobbly based off of how fast you're moving the printer. Motors are constant power, so power is torque times speed. So if you want more torque to resist ship motion, you just slow the machine down. And this printer will slow the machine down based off of the environmental acceleration, which is actually kind of unique. So, you know, we got it over there so you can go play around with it if you're going to be here tomorrow. You can jiggle it around. But it also could do other stuff, right? Like let's say it's cold, right? Then you can increase the nozzle temperature to increase layer bonding. That's all kind of technical stuff, but it basically gives the printer the ability to maintain homeostasis in whatever operating environment it is, while also using the approved settings from the blockchain and only changing within an approved bound, right? Because the rules for adjusting its own parameters are also saved on the blockchain. It's a little complex, but it's actually really interesting. So next slide. So these are our big takeaway key features. We basically said, hey, these are the big 5 things. If you walk away with nothing else, these 5 are the big valuable ones. So blockchain provides an improved configuration control. When you actually make a part and you approve the part and you say, hey, who's, you know, approving this? Who's stamping their name on this blockchain and saying, yes, this is my digital signature, I approve this part. The interesting part is that you're not printing a PDF printout of a technical data package, right? You're actually printing the thing that you approved, right? It says, you know, the whoever signs it, the signature authority who stamped their name on it, that is what you print, right? You're not copying it into a slicer, you're not copying it into a piece of software. You literally are just saying, this is the thing. I know it's true because of this cryptographic hash. It cannot be changed by definition because it's a blockchain, it's an immutable ledger. That is exactly what I'm printing, which is interesting. We've also found because of that, and because we're trying to save all of that stuff to prevent insider threat, we kind of have saved all the information necessary to do the technical side of making the actual part. So by building this little vending machine that automates the process, we actually reduce the user training required to bring it to the fleet. Obviously, there's going to be people who are going to need to make packages, so there will always be a need in the fleet for, you know, writing up and drafting new proposals to get approved. But at least for using the system, it's as simple as just give me this and it goes. It's also got very high tamper resistance. The interesting part about blockchain is compared with traditional normal server-based systems, the more things that you have on a network in a traditional server-based system, actually the less secure your system is. You have a broader attack surface. There's more things that can go wrong and they all have reasonable access to the server. Whereas with blockchain, it's actually kind of the opposite. The more nodes that you have, the more secure it is because there's more people to back up the group consensus algorithm that is the blockchain. So the more people you have and the more of these nodes that exist in the world, the more secure your part files are. And then of course, insider threat protection. I say insider threat, whenever you think insider threat, you think, you know, nation state attacks or some guy in a cat suit, but generally speaking, it's just somebody's not paying attention or they copy it down wrong, or maybe the computer, like, you know, got a sticky 0 key and you add an extra 0 or something. Basically, it just prevents some of those mistakes that come in copying data around, which is very helpful. Plus, you can also protect against insider threat for your approvers. If you have just one person, one signature authority, that's fine. That's a vulnerability, but you kind of have to trust your signature authority. But you could also have multiple signature authorities, and the only way that this printer will ever print anything is if, you know, 2 or 3 of them sign it, or 2 out of 3, or 1 from engineering and 1 from administration, or, you know, something like that. So you can have different configurations of who has to approve the part before the printer recognizes it as a valid component. And of course, our environmental compensation concept. It's kind of in a primitive stage right now, but it's interesting on how you can use approved parts and approved rules saved in a chain to maintain some level of homeostasis in an unknown environment to expand that operating window. So next slide. So I know I can't see questions, so I'll leave you off with this quote: build a little, test a little, learn a lot, which I'm surprised is not the actual like slogan of Antex. But Father of Ages developed this a long time ago of this. Let's build a little bit, let's try a little bit, and then let's see what we learned and keep building from there. And kind of on that note, this is a minimum viable product. We're really kind of reliant on you all to tell us kind of what we can do to improve and how best to scope the next levels of this effort. I know we've built this for additive manufacturing and have, you know, the system and the packages and the differential checkers designed for additive, but you could just as well use this for a bunch of other things like UAV flight paths or like, you know, procurement documents, you know, really anything that needs to be seen by multiple people and you need to make sure that the part you received is the part that you sent. You could technically adapt this system to. So if you have an idea in mind, or if you have feedback, or if you think this is a great idea, if you think this is a terrible idea, let us know, give us an email, and we'll get back to you and talk about it. So, all right, so that's what I got.
All right, thanks, Scott. I think I'm going to take you up on that offer to use that quote, build a little, test a little, learn a lot. I like it. You might see it next time around. But this project's a great example of, you know, we talk about technology being developed and typically you think of the private sector, but there are also a lot of government labs doing research, coming up with a lot of relevant technology for the warfighter and for other applications. So happy to have you brief. Thanks for being here. Okay, our next project is from CenturyView Systems and IXI. It has to do with countering unmanned aircraft. We've been working with the IXI team and their partners for several years now, had their systems when it was handheld. Out on Catalina Island off the coast of Southern California, brought it out a couple years ago onto a ship, had it out at a land-based test site and aboard an oil platform off the coast of Ventura. So we've seen a lot of really neat development and maturation in their technologies. Excited to have them as a part of the program this year as well. I believe our briefer is Mr. Jason Jones from CenturyView Systems. Are you on the line, sir?
Hi, this is Jacob Gardner. I'll be speaking for CenturyView Systems. Jason Jones is unfortunately traveling right now, but he'll be with you all tomorrow and ready to run some live demos. Everyone, I'm Jacob Gardner from CenturyView Systems. We partnered with IXI and Persistent Systems for this exercise. This is our first time joining you all at Coastal Trident. I'm going to walk through a bit about our company and what we do. So CenturyView Systems, we're historically a prime contractor for the Air Force. We provide situational awareness for the Minuteman III system at all the various wings. We've recently been moving into the counter drone area. We're lucky enough to be able to partner with IXI for this effort. We have a number of different services available. We have a fixed system, a mobile system, hardware systems that include radar. We also incorporate IXI's jamming products in those. We also have a software system that we use to bring it all together. So what we offer is, we offer both hardware and software integration. We have scalable solutions so we can put various sensors on our different hardware platforms, provide communications for those. The systems that we brought out to the Coastal Trident exercises, Chula Vista and platform Gina, we brought the mobile system out to Chula Vista, where we were able to move it to different locations and detect and track drones coming in, and also remotely operate IXI's music on jammer. On the platform Gina, we brought a fixed system out there and worked with Decor to get it set up, and we were able to view and track drones and also remotely jam them from Port Hueneme from the operations center. We offer a number of various solutions, including passive RF, radar, as I also mentioned, and a PTZ camera. So at Chula Vista, there was a number of demonstrations that occurred, multiple people flying in various types of drones, different altitudes, speeds. We were able to detect those in a lot of cases and also jam them using IXI's system. Platform Gina, we were able to do the same. So it was a good exercise. It was a good learning experience for us. The objectives here were to identify, track, and mitigate, and to jam them with the music on system. We were able to kind of evaluate deploying our hardware in various environments, which we wouldn't typically be able to. For example, the platform Gina, we learned a whole lot from that one. Validating our Nexus software was really important in this case, and really just getting through really field testing. Someone mentioned in the previous presentation about the testing. It's critically important, and that's how you learn. So we were able to mitigate the drone pretty well universally with IXI's new jammer. The detection characteristics with the radar were interesting over water. We were able to, during setup, we learned that it was far more, our system was far more capable than we initially expected. We were able to track boats and even marine life. So that was exciting. Let's see. So some of the challenges, really the only really challenge that I noticed that we had was really the positioning of the system. The radar relies on line of sight. That wasn't available at the platform. However, the decor crew was really good about getting us into a position where we could still evaluate it, and we had a good range where we could test the system, where we could see drones flying in from multiple angles and at various distances, and also operate the jammer. Let's see some of the other issues we had. We were using persistent systems line of sight radio to transmit back to Port Hueneme from platform Gina, and the positioning of the radios was not ideal. And so we did notice that because of that, when we turned the jammer on, we had a pretty substantial signal loss in the communication. So that's one of those lessons learned that we will be able to take with us going forward. Let's see, we were able to engage with FathomWorks and Decor. We had a good time with everyone out there, very helpful, very knowledgeable, really good experience for everybody. And so, yeah, the lessons learned, we certainly expected the challenges. The setup on the platform in particular was difficult. Like I said, the system relies on really line of sight to function well, and it doesn't do that great with a bunch of metal reflecting in the way. So the setup was non-ideal. We brought our fixed system, which is really meant to be set up on a roof or in an open area and provide 360 degrees of coverage, but this was the asset we had in out west. So we set it up there. Ideally, we would have mounted these things in strategic locations about the platform to get better coverage, but we were still able to get a lot of benefit from this just running in the over the ocean environment. Let's see, and we were a little bit surprised to be tracking the marine life, I have to say. Overall, very good experience. We're taking this as a learning experience to help us get into more of the situational counter drone, counter UAS markets, working with IXI. We currently have customers in the US, the UK, Europe, and the Middle East. So there's a lot going on, and it's a lot of fun. And that's all I got for this presentation. So I'm sorry I don't know the forum. If anyone had any questions, please do feel free to ask those now.
Thanks,
Thank you,
Jacob.
everybody.
Thanks for being here. Thanks for you and the team for participating. You guys are always really good sports with all the crazy ideas we come up with on where to put your systems. But have seen a lot of aircraft fly home as a result of your system. So thanks for your partnership. Excited to see where your technology is going, and I'm sure we'll be engaging with your team next year.
We're definitely.
Excellent. All right, our next brief is by Peter Mennett from Mennett Aero and Rob Ratcliffe from Future Tech Consulting, and they are going to be talking to us about one of their projects, which has to do with unmanned aircraft operations off of vessels at sea. Not only how to tether them and power them for persistence, but how to incorporate autonomy into the navigation. Gentlemen, I'll let you take it away.
Appreciate it. Thanks everybody for attending. And Rob, so I'm Peter Mennett, Mennett Aero, and then with me is Rob Ratcliffe from Future Tech Corporation. Go ahead, Rob.
Okay, I'm just going to give a quick intro of the some of the work I've been doing over the last few years is in support of Peter's test. I own a small consulting company called Future Tech. We build engineering and military applications over the last 20 years or so. We've been developing, acquisition and geolocation controls and GPS denied applications, and then recently with RF link analysis, and then the last 8 years we've been doing supporting a ground station called DPAX, which stands for Distributed Particle Antenna Collection System, that Michael Clark commissioned. Next slide. And then, so it's a command and control plugin. It's based on MAVLink. and it's been funded by NSW and NSWC. Like I said, it was commissioned by Michael Clark, and he's funded it, and it was his original brainchild. Basically, he wanted to have a interface that provided an easy way to control a tethered drone, and so to minimize pilot training, and we did this by providing a mission-oriented interface and workflow. And we wanted to leverage the RaptorX framework, which has GIS support and support for multiple plugins, and where we can overlay different types of ANTs in one map, provide a common operating picture. To support Peter's stuff, I mean, we have right now the operator, all he has to do is connect and then launch the arm and launch the drone, and it'll automatically follow the ship. And then there's another button where I call the guided RTL, where it'll automatically land on the ship without any pilot interaction. So we used RTK GPS, precision GPS, and moving base mode to support this. Go ahead and next slide. So we've been working on this for a while. We did Coastal Trident's been a big help in supporting my test efforts on how well these RTK GPSs work. Back in 2018, we tried it with an M8P GPS, and it just had a really long time to fix, and just didn't work out that well for this operation for moving base mode. So the next year, the F9P came out from U-Blocks, and we got to do a little static test on the independence and proved that the time to fix was pretty quick, and it even was able to fix within a 30-foot. The wheelhouse wall was like 30-foot steel wall, and it was able to get a fix even next to that wall. So it was pretty promising. So then last year, because of the COVID travel restrictions, I basically set up a kind of a surrogate test in Austin, Texas, and did a test with a sled and a little car to mimic the boat. And then we basically showed that we could land on the sled with the moving base, accurately. So then this year we were able to come out with Mini Aero and demonstrate an actual drone landing on a cargo container ship for Coastal Trident. So it's been a big help and development. I appreciate all the support I've gotten over the years from the Coastal Trident team. Next slide. And just to give you a quick overview, basically we have a RTK base on the ship, and then a rover GPS on the drone. And basically the RTK, the benefit of it is it's like a 2-centimeter accurate solution and horizontal and vertical accuracy, even at moving base mode. And it has a very fast time to fix, and I've been seeing basically time to fix within seconds of connecting. So it's a lot better than the M8P, which was minutes. The F9P has been a big help. And I guess that's about it there. So go to the next slide. So I'll go ahead and show a little demo of DPAX just to show you the workflow.
You don't have to click the link, just hit next slide. There you go.
Okay, so yeah, so the operator needs to launch. It'll launch off the boat, and it automatically goes into follow me mode. It'll follow the boat. This is like twice the speed right now, by the way. And then it basically follows the boat using the RTK GPS. And then the operator can specify a given altitude if he wants to go up higher or lower in altitude. And then when he wants to recover the drone, he just hits RTL, which is a special guided RTL mode that uses the basically moves with the ship as it's landing on the ship using the offsets from the RTK solution. And then once it lands on the ship, it'll basically auto disarm, and then it should be perfectly recovered. So I think is that it? I think that's it from my side. So.
Thank you. So I'm Peter Manette of Manette Aero. I'm the CEO of Manette Aero. We've been in business since 2015, and we recently did an acquisition of a company called NTP Wind Power that manufactured the power line tethered systems. basically we focus primarily on manufacturing tethered systems. So all of our systems were built from the ground up to be tethered. We've got systems in every branch of the DoD and other government agencies, and then several large kind of enterprise level commercial clients. So the advantages of a tethered UAS in general. So one of the big things is that they drastically improve the line of sight over traditional telescoping mast antennas. You know, when I was in the Army early on, I mean, we've been using the same antenna since World War I, which is, you know, the OE254. It's this, you know, fiberglass antenna you telescope together, gets you about 40 feet in the air. That was fine for the old analog communications, but with the new digital battlefield communications, it just doesn't go as far. So being able to stick a drone, we've got 200-foot systems, we have 1,000-foot systems. So being able to get your antenna that much higher, or your radio system that much higher, you drastically expand that line of sight over traditional kind of those telescoping antennas. It's got a smaller logistical footprint than aerostats. You know, aerostats is kind of the other competing technology, but trying to fit that on like an 11-meter rib is not really practical, you know, which is, again, some of the applications we're looking at. The big thing is we run all the communications. It's all fly-by-wire, and then we also embed fiber optics, so we can do 10 gigabits of data up and down, and it's near real time. So especially when you're doing these RTK operations, it's a lot easier to deal with a solid link instead of having to deal with stuff over the radio and the latency that sometimes is associated with that, or drop packets, things like that. So it's a big advantage of having, you know, that communication running up and down the tether. You can also connect it to multiple backhauls. We work with one of the largest telecommunications providers in the US, and they do do hurricane support and stuff like that, where they'll pop up a 5G cellular antenna, provide, you know, temporary cellular coverage, and then hook it to either satellite backhaul or a fiber optic backhaul, and be able to, you know, light up an area for communications when it's get knocked down. And then the other thing that, you know, we're getting into is being able to serve as a C2 node for other unmanned aircraft. So you can actually use our system to be able to do aerial relays. We had a contract with the Department of Interior to do wildland firefighting, and one of the more difficult things to do is trying to find an area where you can actually have long range line of sight capabilities over those unmanned aircraft you launch out there. So this essentially allows you, again, to put up a 200-foot C2 node that drastically expands your line of sight and working with those roving systems. So for this particular project, we kind of had two objectives. One was extend the relay of line of sight communications and data links. We know that this is very possible. We've done it before. Last year, we actually did a live broadcast of the 2020 Pikes Peak International Hill Climb, which, for people that don't know about it, it's a 14-mile race up Pikes Peak, you know, from basically 10,000 to 14,000 feet. So what we did was we put 3 tethered drones up on the mountain, and then we had another base station back at the start line that was connected to a satellite truck that was able to take all of our mesh radio networks, all the digital cameras we had on the ground, beam it all down up in high bandwidth up to the top of the peak, where we had one of our large systems that's pictured up in the top left of this image, and basically transmit that all the way back down to the satellite truck, which shot it over to the East Coast. They were able to pull it down at the Mobile One station, and then they had a live event host that was actually hosting it from Australia, and then they sent it out to a global audience. So, you know, the ability to do this stuff, especially in a really mountainous area and kind of really adverse weather conditions and things like that, it's been done. I mean, we've proven it out that it's completely possible and it can be done at scale. So kind of the next thing is like, okay, how do we actually put that on the move? And that's sort of the second objective, the second objective, which was the RTK GNSS, autonomous navigation and recovery. So one of our platforms we built is we have an MRZR, a Polaris MRZR that we've built a system in the back of. Primarily up until we met Rob, we were just doing static launches and recoveries. The system, we've flown it up to 35 miles an hour. Here's just a short video of the system in action. Neat thing about our aircraft, these particular aircraft, we design them with prop protection all around them, because typically when you're working with them, you're in close quarters. And nobody wants to fly super light payloads. You know, we fly a lot of signal intelligence stuff, and electronic warfare, and all that stuff is heavy. So you can't do this with small little drones. So you have to do it with big drones, which obviously are dangerous. So putting the prop protection around them adds a lot of safety factor to them. So this kind of just shows, us driving around the parking lot and, doing some tight turns and the aircraft following nicely. And then this last little sequence was just me doing a dash. I think I was doing a dash up to like 25 miles an hour just to kind of, show the aircraft's ability to sort of keep up. And this was an aircraft that we repurposed. So this wasn't purpose built to really fly off a moving platform. It was just something that we were just testing with. So, and that'll kind of be one of the things I'll cover in the lessons learned at the end. And then, so developing the seaborne capability. So what makes this so special for seaborne operations? Obviously the line of sight, is a big thing. I mean, once at a certain point, you just run into horizon issues. So by putting your antenna 200,000 feet in the air, you get that much further. The other thing that Brendan pointed out when we were on the boat was that, hey, look up at those antennas on the boat. They're constantly rocking back and forth, so the signal propagation is constantly changing with them. So your line of sight, even though it may be a certain amount, is constantly being influenced by the rocking of the boat. So neat thing about the tethered platform is that, it gets up high, it's stable, it's basically just doing little motions to account for the wind. So it's not constantly changing that. With the tether, with the embedded data capabilities, you can use high bandwidth communication up and down them, beam high bandwidth video back and forth, and it's unlimited flight time as long as you stick some sort of power in the ground station. And then the challenges of all that is the on the move, launch and recover, and the follow me operations. It's definitely something that we, when we were out on the boat, that we've now met the enemy, and nothing survives first contact with the enemy. So we've got some work to do, but we did learn a lot. We were able to do some successful flights, and then we also kind of noticed some just flight characteristics which you hadn't noticed on the ground-based platform, because when you have the boat kind of doing the heaving, the rolling, the sliding left and right, and all the other motion that goes along with that, there's a lot of stuff that kind of plays into the software that we just hadn't accounted for prior to the operation. But overall, the flights went fairly well. We had nobody got hurt, nothing got crashed, and it's always a good day when you're doing testing on new aircraft and new applications. So the next step really for maritime operations for us, I mean, the big takeaways that we took away from this event are that we need to optimize the aircraft for moving, takeoff, and landing operations. There's some actual physical changes we need to make to the aircraft, power plant changes, things like that, to make it better at being able to fly off a moving platform. The nest that we land in and out of, we kind of just put together something temporary for the boat, but we're looking to basically optimize the way that was put together so that it can land in a tighter area and not have to take up so much deck space. Again, we're trying to put this on an 11-meter rib, so as well as several other platforms. So just not going to have the real estate's only going to get smaller compared to the Atlas. So that's one thing that we're kind of working on. And then our other thing is we want to test it off a variety of maritime platforms. Is really the next big push for us is to fly it off a bunch of different types of vehicles. So we know this will fly off a big ship, small ships, sheriff's boat, all type of stuff. So Rob, I don't know if you want to talk about your takeaways.
Yeah, just mention a few things from the flight control perspective. We did prove that with the F9P that it was able to get a moving base solution between two steel walls, on either side of the ship. The containers and the wheelhouse provided a blockage from part of the sky, so it still worked there and worked on a moving ship. So that was good. One thing we noticed is the GPS was on the ship was up about 10 feet from the sea. So as the boat rolled, it provided a lot of movement back and forth, and the drone was trying to catch up with that pretty rapid change horizontally that we hadn't modeled or tested on ground, because you can't really do that very well. So we're gonna put in some logic to account for the pitch and roll of the ground station, so it doesn't so the drone can basically predict where the basket will be based on the roll and the pitch. Also, there's it's 2 centimeter accuracy. There's a lot of small changes being made in position, and so that kind of causes the copter to twitch a little bit. So we need to smooth that out. And also, like even Brendan mentioned, we don't really need two centimeter accurate solutions at high altitudes. We can just basically get close, and so we don't need to have a lot of small corrections being made at high altitude, and then only when it gets close to landing we can make the small changes necessary to land on the basket. So that's a couple things I'm going to work on. So
this is just for people that are going to be attending tomorrow. We're actually going to be bringing out one of our new aircraft. It'll be the first time we kind of publicly show it off. It's a man-packable system. We'll have it on display tomorrow. You know, again, the idea behind it is something that can easily be moved by a, you know, a single soldier, putting them, you know, easily transported around. It's got a built-in, we put mesh radio on and EOIR camera with targeting tracking on it to be able to, you know, kind of take care of the role of, you know, communications relay as well as force protection and, you know, targeting type of capabilities in a single platform. So that'll be on display tomorrow. So questions and answers. I don't know if anybody had any questions. Here's our contact information. Please feel free to reach out and give us a call or send us an email. We'd be more than happy to talk to you about what we have to offer.
I'll have the simulator at my table tomorrow. So if anybody wants to just try out the GUI with the simulator, you can do that. So.
Yeah. Thank you very much, Brendan and the Phantom Works team for having us out here.
Yeah, thank you.
It was a great exercise.
All right.
All right. So Peter and Rob get the award for the video working the first time around. Nice job. Nice work. Thanks, guys. We've been working with Rob for several years on the DPAX problem and been looking at tethered drones for a while for a number of different stakeholders. So really excited to see those projects progressing and that capability getting ready to transition. Our next brief is from Jyrene. AJ Scotty, are you on the line, sir?
Hello.
Okay. AJ, can you? Yeah, we got you now.
Awesome. Perfect
Okay,
timing.
awesome.
Yeah. So are you going to click through the screens, my friend?
Yeah, I can run your slides.
Okay, thank you. So my name is AJ Scotty. I'm with a company called Jyrene. We've built and designed a atmospheric water generator to a point. We actually call it a water harvester because it's integrated. The technology is integrated with reverse osmosis and a battery pack system. And it's been one of those things that's been something that we've wanted to do as warfighters. I'm a Marine. The CEO is a Marine, and then we took on some way smarter Silicon Valley engineers, aerospace, space engineers to be a part of this. So we started off about 3 years ago. We presented to our first show was an ANTX show, East Coast. Where we received a phase 1 commercial solution opening. And then we provided that that demonstration or a demonstration of 2 prototypes. We call it the P1 Alpha and the P1 Bravo. Those were either vehicle integrated or standalone systems. We got a lot of traction. I showcased it to the Assistant Secretary of the Navy and also the Assistant Commandant of the Marine Corps and a bunch of stars, generals, and admirals. And it just created its own little momentum. So we decided to move forward and pursue this, trying to get contracts with the Navy and the Marine Corps first. And under the last, I would say, year and a half, we've created a lot of momentum with the Air Force ecosystem to include AFWERK, giving us a phase 1, phase 2, and we just solidified a phase 3 contract with 52 Civil Engineering Squadron outside of Germany. Technical performance. We've basically broken it down into 2 technologies. Our first technology is is a little bit better than your typical compressor condenser systems, making about 20 gallons, a little bit more than that, about 24 gallons per day out of about 60% relative humidity. Our Tech 2 system, which is doing wonderfully well. We've developed a patented gelid system, is what we call it. It's a cold core technology that basically drops the energy required to condense water out of the air, and increases basically the overall efficiency of the system relative to other AWGs by up to 60-90%. We are, like I said, we do have a phase 1 and 2 with the Air Force, and we got a contract right now with them, and we're taking the momentum from what we've done to trying to help warfighters. We've now pivoted into the commercial sector, and we're focused on building that out in a certain sector. I'm not going to say right now because we have some NDAs. We got to prove some stuff out, but that's been a wonderful thing because that's lowered this whole push into the DoD, has lowered the barriers of doing business to the commercial sector, and our team's pretty focused on the whole national economy, national defense, national security thing. I hope I covered everything. I think I did. Let me talk a little bit about the technical performance. It is a multi-purpose, dual functioning system. As a water harvester, it can do more than just grab water out of the air and turn it into potable water. We have the capability of producing through a reverse osmotic system that's commercial off-the-shelf technology that we've integrated and applied some wonderful metrics on top of it. It can do about 15 gallons per hour, roughly 360 plus a day. The battery pack system is standardized and approved by the Navy. It's a 12.9, right now it's about 12.9 kilowatt exportable power system. So what that does is allow the system to be standalone. You can hook it up agnostically to different power inputs to include grid, solar, wind, you name it. If you have power, you can connect it. And we are playing with some different sorbents right now to kind of reduce the relative humidity environment that this can operate in. So I think that's going to be it for now. Is there any questions?
That's great, AG. Thanks. So the gyrene projects are a good example of some of those projects that I talked about earlier that were read and withdrawn because they progressed beyond the point where they really needed to be tested in our environment. So we were working with gyrene on 2 different projects. One was an airfield damage patch, an expeditionary patch that could be used to repair airfield damage in expeditionary missions. And the other one was durable coatings for weapon systems, small arms systems. And those were going to be Coastal Trident projects. And in talking with AJ and his team, those projects had progressed beyond the point where they really needed to use ANTX and Coastal Trident as a demonstration environment. So those were ones that we were happy to see drop off the table, and happy to work with the gyrene team. Okay, so our next briefer, Senior Chief Jim McVicker from NAVFAC EXWC, the Naval Facilities Engineering and Expeditionary Warfare Center. He is actually on his way to FathomWorks right now. He and his team are diving on the port, doing some exercise and some training this week. So he, because we're a little bit ahead of schedule, he's not going to make it. So what I would like to do is skip to the sail drone team, so they can talk about their autonomous surface vessels. If the sail drone team is on the line, I can skip to your slides if you're ready to go.
Hi, this is Kim Sparling from Sail Drone. Yep, happy to go now. Great. I guess I'll go ahead and kick it off. Hi, everyone. Thanks for listening in. My name is Kim Sparling. I'm the VP of Product here at Sail Drone. What you see on this slide here is a picture of our Sail Drone Surveyor. This is our largest unmanned surface vehicle. We're based in an old Navy hangar in Alameda, so based in the Bay Area, which is why you can see the Golden Gate Bridge here. Next slide. So just a little bit of information about Saildrone. We are, as I mentioned, we're located in Alameda, California. You can see here an image of our production floor. This is where all of our Saildrone USVs are designed, manufactured, assembled, and maintained. So we're doing all of this here in Alameda. We treat each drone that we produce and go through a rigorous QA, QC process to get them on the water. We actually operate out of the San Francisco Bay quite regularly. Over the last year or two with COVID, we actually would sail drones from the San Francisco Bay Area around the world because we couldn't get our personnel into different ports to deploy them. So these are long endurance, persistent, uncrewed vessels. And as a company, we are around 100 employees right now and continuing to grow. Next slide. So what you see here is what we call our Explorer platform. This is the smallest USV that we produce. These are fully unmanned autonomous maritime surface vehicles. And so when we say autonomous, these are sort of working with pre-planned mission plans that have been provided by our Saildrone operations teams, and the drones autonomously navigate from waypoint to waypoint, taking into account different wind conditions, current conditions, environmental factors, and there's all onboard autonomous logic for different sailing behaviors. For our Explorer platforms in particular, they were designed to stay on mission in extreme environmental conditions for up to 12 months. And these platforms in particular rely solely on wind for propulsion and the solar panels, which you can see here, and a small hydro generator located on the keel for power generation. This power generation goes into onboard batteries, which we use to power our onboard computer, sensors, and different communication devices. These drones all have redundant satellite uplinks on board so that you can sort of interact with the data we're collecting in near real time and use that to make different operational decisions. So as I mentioned, we sort of design our sail drones to be extremely seaworthy. They've encountered very heavy sea states. And in fact, we have a fleet of 5 located in the Atlantic right now, actually doing monitoring with the National Hurricane Center to gather observational data around those extreme conditions. Most of our drones have a 0 carbon footprint when they're deployed. So the Explorer in particular, relying solely on solar, wind, and hydro generation for power. Next slide. As you could see in the picture a few slides ago, we have about 100 of our Explorer platforms built, and we've been operating them regularly with different partners for the last 5 to 6 years. Here's a subset of some interesting missions that we've done. In total, we've had our fleet sail over 500,000 nautical miles at sea. We've spent extensive time in the Arctic. So we've operated in the Arctic spring and summer with NOAA Fisheries and with NASA, with the Pacific Marine Environmental Lab, part of NOAA for the last 5 years. We've done regular surveys of the West Coast for different fisheries organizations. We've circumnavigated Antarctica and have worked across a number of different oceans around the world. Next slide. So we actually, in addition to the Explorer class, which is what we've talked about thus far, we also have 2 other varieties of vehicles. So on the right-hand side is our Surveyor. That was the picture on the intro slide. This is actually our largest platform and was designed for full depth ocean mapping. So in the bottom of the keel, there's a number of different multi-beam echo sounder sensors that you can use for mapping the seafloor down to 7,000 meters. In the middle, we have our Voyager class. This vehicle is in active development right now. It's in between the two sizes, so at roughly 30 feet long. The key sort of target use cases for our Voyager class vehicle are shallow water multi-beam and persistent maritime domain awareness or ISR applications. The Voyager and Surveyor class vehicles have small diesel electric engines. We use those for propulsion occasionally, but really the main need for those engines are for power generation. So when you have the very large multi-beam echo sounders on board these vehicles, you need more power generation than what you can harvest from solar panels alone. On board the Voyager and Surveyor, we also see additional payload capacity for radar, passive acoustics. You can see we're designing both of these platforms to have winches so that we can do various casts to collect profiles of data along the water column as well. Next slide. So I'm going to be talking specifically about maritime domain awareness. Saildrone covers other use cases, like I mentioned, deep sea mapping and bathymetry. We've also been working to collect high quality oceanographic data for the last 5 years. That data is used for fish stock assessment and for weather modeling, but I'm specifically focusing on MDA for the purposes of this ANTX demonstration. Next slide. So over the past 6 years, we've had our USVs deployed around the world, basically collecting images anywhere from every 5 minutes down to every second. We think, I'm not sure if this is confirmed, but we own what must be one of the largest databases of open ocean images collected by the fleet that we have distributed around the world. We've actually sort of worked to annotate those images, and we've basically developed a deep neural net based off of that. That net is used to detect other objects at sea, specifically vessels, like what you can see here on the screen, but then also other objects like birds, sea ice, for example. So we have that model that we've developed in-house, and what we've done is actually built an integrated GPU on board the drones. It's integrated into the electro-optical camera that we deploy on these drones, and we can run this model in real time to detect those objects. Next slide. So in addition to using that camera system in our machine learning model, we also perform sensor fusion on board the drones as well. So all of our drones are carrying AIS devices. So we're actively collecting AIS data from other ships at sea. And for our Voyager and Surveyor class vehicles, they're carrying radars on board. So we leverage the sort of existing ARPA technology to fuse that data with AIS and data coming out of our machine learning model as well. So combined, you sort of get a real-time update as to what other vessels are around the sail drones when they are deployed. Next slide. And so in addition to fusing data on board an individual sail drone, so when we fuse the camera data, the AIS data, and radar data, we're also fusing that data across drones on our server. So really what you're getting when you have multiple sail drones deployed with this capability is almost like a mesh network for ISR and MDA. So you can leverage a fleet of drones deployed to get real-time notifications of targets that have been identified through our camera system, through AIS, and through radar, or a combination of those. Next slide. And so I've mentioned that all of this is happening in near real time. We leverage our satellite uplink to send data back regularly from the drones. So this can span anywhere from every hour to every few minutes. Most of the customers that we work with rely on our mission portal technology. This is a secure web application we've built for visualizing sail drone data. And so within Mission Portal, we display the sort of oceanographic and environmental data we're collecting, but then we also expose our MDA data as well. So you can see here images, we'll draw the trajectory of the target as we track it over time, also provide information and other metadata about the vessel. For example, its MMSI, speed, its course, bearing from drone, and if we have the location, the actual details of it for that target. In addition to providing Mission Portal as a tool to view this data, we also have different data feeds that can be exposed so that the sail drone data that we're collecting can be integrated into existing COP applications or common operating pictures. It can be sort of integrated with other sort of higher classified data to give you more situational awareness around a specific area at sea. Next slide. So last year we actually performed a demonstration with the U.S. Coast Guard RDC Center. We were located off the coast of Oahu. So you can see we had 6 sail drones deployed in the green box was our sort of operational area to perform different exercises. And really what we were trying to demonstrate was the ability to use sail drones as a high endurance platform that leverages machine learning and sensor fusion at the edge and high bandwidth satellite communications for a highly persistent over the horizon ISR solution. You can see just what we're displaying here on this image are all of the targets that we spotted over sort of a short time period entering and exiting the port of Honolulu. And this is using a combination of vessels that we identified through our machine learning system and also through AIS and fusing that on board the drone and across drones that are deployed on a mission. Next slide. That demonstration in particular was focused on detecting and alerting on different activity that's associated with illegal, unregulated, unreported fishing or IUU fishing. One of the common types of behavior that's associated with IUU fishing is transshipment events. So this is when 2 vessels might be loitering near one another in open ocean. Often transshipment events are associated with the transfer of illegal goods, illegal catch, or people. And so you can see here, this is just like one example of when we were able to detect 2 vessels in frame. So the green box sort of indicates a box around sort of a primary vessel that we detected, and the pink or magenta box represents a secondary vessel that we picked up in the same frame. Identifying multiple vessels in a single frame for a specific sort of long period of time could be indicative of transshipment events. So this is just one example of us just sort of taking our baseline technology and trying to push it further to sort of identify different behavior patterns. Next slide. Another sort of key aspect of IUU fishing that we were focused on was monitoring different restricted areas. So we had the 6 sail drones involved in this exercise loitering or holding station along the edge of a red zone, sort of just an area we defined as a restricted area. And during that day, we were responsible for identifying when different vessels would enter or exit this restricted area. So you can see how having the different sail drones stationed along the edge of this restricted area provided almost like a picket fence formation to identify any traffic going into areas that other traffic should not be entering. In addition to our MTA ISR systems in the form of the camera and AIS device, these sail drones are also outfitted with a number of different scientific sensors like barometric pressure, air temperature, wind speed, wave direction. And these in particular were outfitted with acoustic Doppler current profilers, which is a sensor you can use to measure the speed of different water currents at depths along the water column. And so in one day of this demonstration, not only were we able to identify a vessel sort of skirting the edge of a restricted area, but understanding how water currents could effectively change its course as it loitered, or change the sort of location of the lines it was setting. Next slide. So taking that and applying it to other use cases, we think that you could use our USVs for monitoring different strategic areas. This is an example of doing, using a picket line formation between a specific strait or passageway of strategic importance. So taking multiple USVs and spacing them, 5 nautical miles apart, so that you can identify any vessels that are going between the drones for that area. Next slide. This is sort of an example of us performing a sort of similar strategic exercise outside the port of San Francisco. So the pink lines indicate potential shipping lanes. We think that one way you could apply this technology is by stationing sail drones spaced throughout those shipping lanes to identify any vessels that might be passing through. And this is sort of extending the vision and range that you might have for monitoring who is entering and exiting the shipping lanes or moving towards a port entrance. Next slide. And likewise, this is, what we just saw was an example around the port of San Francisco. This is sort of taking it to specifically in the context of ANTX. What would this technology look like if we were using it for monitoring or surveilling the port that this demonstration is happening in? We believe that this is sort of the right placement, and you could identify or extend the range of monitoring for port surveillance or other critical infrastructure monitoring. Next slide. So in terms of the sort of capabilities we have and what we're working towards, as I mentioned, we do currently have our own sort of machine learning model where we're fusing data from our cameras, radar, and AIS system. We're leveraging satellite communications to send that data in real time. Really, the sort of next steps for us are, getting that technology deployed across other geographies and with different partners, getting more time and iterating on that that functionality, but then also adding other capabilities. So for example, integrating different passive acoustic technologies to identify low profile vessels that are difficult to spot either visually or through radar, and then also potentially for undersea vessels as well, using that same passive acoustic technology for detecting other vessels beneath the surface. And all of this is being done while we are collecting other types of data. So for example, seabed mapping, weather data, fisheries data. This is a dual use platform. I think that is it. Next slide. Great. So we will have a booth at the demonstration tomorrow. And if you have any other questions, happy to answer them or talk to you in person tomorrow. Thank you.
All right, thank you so much. As you can see from Kim's second slide, this is a capability that is very mature. They're deploying it in a bunch of different locations, and so they're not looking, to learn about a low readiness level technology here. They're looking at applying this proven technology where it can be of use, and the Navy is definitely looking at persistent surface vessels in many of the roles that they've already demonstrated the sail drone in. So we're excited to work with them further on implementation and see where we can apply these technologies to port and maritime security. Can we go back to the EXWC slides, please? So our next brief is going to be by Senior Chief Jim McVicker. He's a master diver with the Naval Facilities Engineering and Expeditionary Warfare Center, and he's going to talk about the dive training and exercises that they've been conducting during this year's program and some of the technologies that they've been taking a look at.
As Brennan said, my name's Jim McVicker. I'm the master diver of EXWC's Dive Locker. Basically, we do working tools for working divers. Our work with ANTX and the Coastal Trident exercise really kind of revolved around two things. I wish I had an amazing slide deck full of a bunch of photos. but we're actually currently diving right now. So you get what you got. What I would ask is if you do have any questions, go ahead and throw them in the comment section. When I get to the end of the brief, we'll ask for those, and then I'll try and answer them the best I can. Let me see if I know which one's the next slide. So really there were kind of two goals. The first one was a window that we had in late June that was a mass casualty drill. It was designed to benefit local dive teams and some government divers. What we did was we took a 20-foot container, kitted it out as if it were a berthing structure, loaded it full of mannequins and other items that need to be investigated and documented. And we sunk it in the harbor in about 40 feet of water. This let us bring together a team of about 45 different divers. We had U.S. Navy, U.S. Coast Guard. We had Ventura County Sheriff's Department Search and Rescue Dive Team, Santa Barbara County Search and Rescue Dive Team, LA Port Police, and LA Fire. Let us get everyone together to kind of train on the scene as a unit, which doesn't happen often, but when it does happen, I can say from experience, it's a mess. And that was good. So we're able to do that. At the same time, what we were doing was using that, for the Navy's interest to take a look at some advanced sonar technology and the diver's augmented vision display. So we were diving the augmented vision display in the same time where the law enforcement dive teams were going through and using their tactics and techniques to do penetration dives, to document the scene, and then to recover casualties. We were taking Navy and Coast Guard divers, putting them in a hard hat with an augmented reality display embedded in, and then using that to navigate them in, reset the scene, and to just explore how the augmented reality could help a diver in bad visibility. So I'll go ahead and click through a little bit more. If you look at the screen, so you see that's a 20-foot shipping container. Not a berthing structure, but pretty close. We do use these quite frequently. And as far as the dimensions on the inside, it would be a spacious berthing compartment. Even that being said, without it being crushed, a lot of the divers had a hard time navigating. For the Navy, we all know that recently we've had a number of incidents where we've had our surface vessels and our surface vessels berthing compartments affected. And I know a lot of divers that have gone in and done that work. It's challenging to say the very least. And for the local law enforcement teams, if you go back to 2020, we had the Conception right offshore, where we had dozens of casualties aboard a vessel that went down off the islands. That was one of those instances where we had the Coast Guard out. We had the Navy in what capacity we could help. Not much, if I'm honest. And then we had a bunch of local law enforcement teams that all came together in a pretty tough spot to try and recover as many folks as we could in as fast a time period as we could. So this was pretty good for the local teams, giving them the ability to get back out, give it another shot in better conditions, and allow them to exercise that integration a little more. So that shows the corner of Wharf 3 and Wharf 5, I believe it is, on Naval Base Ventura County. And that container went down to about 40 feet of water. The team, like I said, 44 divers from all those various units. They were on site for a week. Everyone got a chance to exercise really whatever their training teams wanted. Some teams wanted to do full-on enclosed space penetration body recoveries. Some wanted to explore the wreck with their ROVs and their sonars. They were all able to do that. We had some newer teams. Santa Barbara is a relatively new team, very professional and off to a great start. Most of their folks are new. So they were doing recoveries and documentation just kind of on the outside. So it was a great event where we let them come in and exercise what they needed to. At the same time, for the David's program, we're using this to get reps on the system. For those of you that are not familiar with the David system we have Code Octopus is the vendor. They make, shamelessly selling for. They make the best sonar I've ever seen, to be honest. And it, in the configuration we have, can render 3D point cloud that we can then send down to the divers. If you look in the screen, you'll see the kind of corner where we were. You see the piles go all the way down, and then in the middle, you see the Connex box. So if I had pan, tilt, and zoom, I could roll this around in 3 dimensions, and that's what we gave the divers. The divers are able to look either from a top down, third person from this perspective, or they can be fully immersed in the 3D sonar map. Visibility wasn't too bad when we did this week. They had about, you know, sometimes it was as good as being able to see 3 feet. Sometimes you just couldn't see anything. So the ability for them to drop down and navigate in the sonar world definitely helped them out. We also have the ability to, if you look in that on that screenshot, we can put like headers in the 3D environment. So you can tell them, hey, this is where you're going to insert, this is where you're going to extract, this is where you're going to navigate to. There's a danger area over here. There's some kelp, there's a debris field. And then if they have, you know, a mission to do, we can send that down to them in like a PowerPoint slide deck. We can even send video clips. So I thought it was pretty good. All the divers, you know, had good things to say about it. It is a developing technology, so it has bugs, and we're able to work some of those out here. One of the things that we also did was, and this is, forgive me, it's kind of a bad image, but like I said, it's the best I could get that showed what we did. Before we sunk the container, we took a handheld LiDAR scanner, we scanned it on surface, and then we rendered that into a format that we could put in the David system and in the sonar map, sunk it, you know, digitally sunk it down into the sonar so that when the divers navigated up, they had a real high fidelity image that they could navigate within. This is a relatively new feature for the David system, so we had to work out what is exactly the workflow, you know, from getting it scanned to getting it to, you know, show up on the divers goggles, and that's just kind of a picture of that. This shows the David helmet as configured. For those of you guys who are not familiar with Navy diving, this is a KM97 Kirby Morgan manufactured. This helmet is dove throughout the U.S. Navy, all over the world right now. And then if you look in the faceplate, you see the David's HUD, which is, you know, I kept saying like Google Glass to people, but I don't know that Google Glass is really that relevant these days. It's a heads-up display that you can send everything down to the divers. One other thing that we did, again, I'll just back up one slide. The David system KM97 with the sonar, everything I already talked about is currently available. It's being issued out to the fleets, underwater construction teams, ships husbandry teams, and the mobile diving salvage units all have this capability, but it's currently a hard hat capability. What we've got right here is a David full face mask, printed faceplate. And what we're doing is, as we move into a free swimming mode, not getting away from, but adding to the hard hat platform, the ability to do it with a regular band mask you could use in scuba. So this particular one is an SLA 3D printed faceplate that was done by NSWC PC in their additive manufacturing lab. The yellow portion that you see around the outside is a standard Navy Mark 20 mask. It's the one we've been diving with minor revisions for the last couple of decades. The clear portion in the front is that 3D printed component. And what we're getting after is being able to insert the existing David goggles into this faceplate without having to go through and do a bunch of injection molded polycarbonates that all cost tool and die manufacturer, you know, 100 grand or so to burn one of these out for us. We're 3D printing them and then diving these so that we can get it in the hands of the divers. They can do form, fit, function. They can let us know what they like, what they don't like. There's a lot of what they don't like in the feedback, and then we can make it better. NSWC PC prints these out in Florida. And then what they'll do is, as they make a change, they'll send that STL file over to EXWC. We'll print it out with a filament type printer so the guys can get their hands on it. there's no, you know, a 3D PDF or a CAD model is great, but putting something in a warfighter's hand is the way you'll really know. So we can give them then feedback on that design. They can tweak it. And then currently, actually, when I get done with this brief, we're going back out to test the version 2. It's got increased field of view, better focal distance, and better vision for the display. We anticipate that we're going to keep doing revisions to this until we have it where we want it. And then at that point, should be able to be mass produced. This is the best shot that I could get because, again, we just dove the version 2 yesterday in the dive tank. This is Professor Tyler Alt diving the version 2 system, much greater field of view. And then this one also has, if you look to his left, your right, infrared camera built in. One feature I don't have on the slide deck, the David system. We're working with the ability to use an infrared camera and infrared lights to do object detection and edge detection that'll allow divers to have an overlay with images popped out. If you could picture yourself in kind of dark, murky water, you turn on a flashlight and all you see is backscatter, all you see is mud and floating debris. It's very challenging. So even though it's dark, a light doesn't help. So if you can shoot an infrared beam and then the computer can take that infrared beam and pop out an edge for you, then you save the diver's night vision. They can keep what normal vision they have and get increased edge detection. So again, a very developing technology, but something that we're working on. And I think that pretty much wraps up the slide deck. I'll let you guys enjoy that, that picture from 1968 of my same dive locker with pretty much all the same stuff that we were testing 53 years ago. And then I'll ask if there were any questions in the comments box. No questions. That means I did a great job, shamelessly. Brendan, I'll hand it back over to you.
All right, so we've been working with Senior Chief McVicker and his team for a number of years, and it's always very exciting to work with them because, like he said, they're working on solutions for the working diver. They're very interested in the need. They're very interested in trying out new technologies, and they're not afraid to tell you what they really think. So we get a lot of cool stuff in their hands. We get a lot of cool feedback to the people who are developing them. And just want to talk about the questions a little bit. I know there are folks out there that have questions because I've seen a couple of them come at my email. I don't know if we're able to catch them all via chat. If you're sending them, we are catching them. But if you do have questions, you want to reach out to any of the presenters or any of the speakers, feel free to just drop me an email and I'll make those connections for you. So if we're missing something, let's make sure that we get a follow-up. So that's all the briefs we have for today. I'm just going to talk a little bit about what we're doing tomorrow. Thank you all for bearing with us, paying attention, being here, joining us on this this experiment. I think the fact that we still have a number of folks, almost 70 still on the line, is a testament to the fact that we're doing really interesting stuff. We're doing stuff that matters, and we're going to keep doing it. So thank you for being here with us. Day 2 is our in-person day. So as we said earlier, today is the content, the stuff that would be, briefings up on a stage with you all gathered together around round tables. The goal was to mitigate that, to go with small group gatherings rather than the large group gatherings as a COVID-19 mitigation, because we prioritize safety. But we are able to gather in person tomorrow and have those one-on-one engagements, the contact, if you will, to supplement today's content. So tomorrow is going to be focused on the engagements that are the follow-up discussions to what we talked about today, whether it was the operational stakeholder discussions, which was talking about needs, whether it was anything having to do with ANTX or Coastal Trident and the stuff that we're doing next year, or more importantly, all of the projects that we've been executing for the last 5 months since May. A lot of those teams are going to be here with static exhibits. We're going to have several live demonstrations out on the port that we can go visit, one of which is the dive lockers, dive operations. And so there's a lot of interesting stuff to see, a lot of opportunities to talk to interesting people, and hopefully we're able to formulate some collaborations and some opportunities for for projects for next year. Like I said, presentations are going to be limited in order to avoid the large gatherings. We'll have some opening remarks, and then the rest of the day will look like this. So opening remarks and welcome starting at 9. We'll have some briefs by our FathomWorks stakeholders at the Port of Hueneme, at the Economic Development Collaborative here in Ventura County, our partners at Matter Labs, and then we'll kick it off. The rest of the day is going to be primarily largely unstructured, just opportunities for you to network and engage and go see stuff and have the discussions that, you know, really result in the work that's going to come from this year and from next year. We're going to have lunch at 12 o'clock. All those lunches will be individually boxed and served by designated people. So we're not doing a buffet style. It'll be COVID-19 approved. And then continue the demonstrations in the open house format at 1 o'clock through the rest of the day. Starting at 1 o'clock, we're going to have several opportunities for you to sit down with some of the stakeholders that talked today and link their needs with your solutions. So we'll have a schedule for those available tomorrow morning. And again, it's just an opportunity to sit down with the people that talked today about the things that they need. If you've got something that can solve those needs or address their problems, then it's a good opportunity for you to talk about how you might move forward with that, whether it's a project in next year's program, whether it's a cooperative research and development agreement, whether it's another type of agreement or, you know, a format to work together. That would be your opportunity to lay the groundwork for those engagements and those collaborations moving forward. We'll close up the program at 4 o'clock, and we'll have a social and tear down and get ready to start planning next year's program next week. So again, thank you all for bearing with us, for paying attention to the briefs, for participating in this virtual event. And I can get the last slide. Let's do it. Oh, I'm sorry. I want to talk a little bit about how we get on the port tomorrow. So most of you are used to entering the port through the main gate on Hueneme Road. That's not what we're going to do tomorrow. The port has made special accommodations to allow us to enter through the Clara gate up near the top of the screen. And they will have a gate guard and people who can help you park your vehicles there. If that lot fills up, that's just adjacent to the FathomWorks space right here, we'll need to be parking out on the street, on Panoma Street. And we will have vans available to transport people onto the port from there. So again, do not try to enter through the main gate. You'll get turned around, come through the Clara gate, and there will be signs directing you all where to go. We will be in the warehouse here at FathomWorks for the day. And like I said, there will be several demonstrations out on the port that we'll be able to take you folks to in vans. And we're working out how the structure that's going to go, but it'll probably be vans leaving every hour to different points and first come, first serve basis. So pay attention to that tomorrow when we give you guidance for that. And now the last slide, right? That's it. See you tomorrow. All right. Like I said, any questions, any follow-up opportunities, feel free to shoot me an email directly and we'll get you linked up. Thanks again for being here. We will see you tomorrow in person.